wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, well, I don't wanna jinx it, baby, and twist myself at the spine. Don't wanna overthink it, baby. It's just twist your body and mine. Baby, you give me ice and fire. You're giving me wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, but I don't wanna jinx it, baby. Let's not get ahead of my time. Oh, but I don't wanna miss you, baby. So I stand up and speak my mind. Oh. Baby, you give me ice and fire. You're chilling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, oh, appetite. Don't leave me here high and dry. Oh, well, I don't wanna jinx it, baby, and twist myself at the spine. Don't wanna overthink it, baby. It's just twist your body and mine. Baby, you give me ice and fire. You're giving me wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, but I don't wanna jinx it, baby. Let's not get ahead of my time. Oh, but I don't wanna miss you, baby. So I stand up and speak my mind. Oh. Baby, you give me ice and fire. You're chilling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh. gonna butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh.
Good morning, everyone. I want to get started a little bit early because I want to make sure that I don't cut into any of the time for Aldo here because I'm really looking forward to this talk. So I just want to go ahead and, as behalf of the PasswordsCon staff and BSides, welcome everyone here to Vegas. You know, this is a really cool thing to be doing this again here, okay? Just to take the energy down a notch here, I just have a few announcements just to start off things here. So first of all, I guess we're contractually, I really want to thank our sponsors because we wouldn't have this here, if it wasn't for them. So thank you, Adobe, our gold, our diamond sponsor here, as well as Toyota, Semgrep, and Blue Cat. So thank you. We really appreciate this. I love doing this here. You make this possible. So I really appreciate this a lot. Also, for cell phones, these talks are being streamed on live here. So please, don't have any side conversations on your cell phones or anything like that there. This is a passwords contract, so I'm sure we can go ahead and figure some way to be able to deal with that if it happens here. Also, kind of really real quick here, we've been doing PasswordsCon for a long time. Haven't we solved this problem or something like that there? And the answer is obviously no. But one thing I just kind of want to, get a little bit of an audience Q&A start off here. But who here has had their password stolen? I certainly have. I've almost getting bored of this now. It's like, oh, my password got stolen again. I guess it's a Tuesday. So let me go ahead and tell you probably the worst data breach I've ever been a part of. So when I first graduated college, I loaded up literally everything I own into my car, and I was going, job searching and stuff like that. And one day I woke up, came down from my hotel room, and the back window of my car was broken, and I found out I owned significantly less stuff. So some of it was really kind of annoying. I had disassembled all my furniture, so they stole the bag of all the bolts, which is just mean. But they also stole all of my important documents because I had left them in my car. So they got my birth certificate, they got my social security card, they got my passport, they got blank checks. Literally, if you can think of something that's physical that you don't want to get stolen, that got stolen from me. So I might not actually be Matt Weir. I might not be I might be the person who broke into the car, as far as you know. But I was able to recover from that. I was able to go ahead and get new credit cards. I was able to get new checks. I was able to get new IDs. And I think that really speaks to kind of the resiliency of this authentication, of the fact that I can suffer the worst possible breach that you can even imagine, and I was able to still be able to recover from that. And that's where I think, passwords are really a big role of this too, because we have so many different problems with passwords. We get them stolen all the time, and yet we can still book plane tickets, we can still show up at Vegas, we can still, have the hotel, accept our credit cards. And I think that really speaks to, the value of all the hard work that everyone here has been putting into this type of field. So, an obvious question though is, why are we still using passwords? They get stolen all the time. Can't we move to more of a passwordless type of an option here? And that's why I'm really excited to go ahead and introduce Aldo here, because he's going to tell us about some of the challenges that occur when we go ahead and move to this here as well. So can we all go ahead and give a hands here to Aldo?
All right, thank you. Thanks for that introduction. Well, my name is Aldo, and I'm here today to talk about passwordless and passwordless security. So it's actually an honor to be here in PasswordsCon, and I was a little bit nervous to be the first one to be speaking today, but actually quite the opposite, because that actually takes the pressure off, because if this talk sucks, then the bar is going to be so low for everybody else. So if anybody here is a speaker, you're welcome. So let's try to make this talk suck a lot for all of you. All right. So yeah, who am I? Right? So I've been doing AppSec for about 15 years, a little bit more, from doing pen tests to code review to everything in between. I am also an OWASP chapter leader in my city. And right now I am running the application security program for Hyper, which it is a passwordless startup. It's kind of ironic that I'm talking about passwordless vulnerabilities, but it's going to make sense, trust me. So before I begin, can you just let me know how many people here are developers? All right. What about pen testers? Nice. And is anybody here already using passwordless either at work or in your personal devices? Awesome. Cool. Thank you. All right. So let's get started. So let's begin by answering this question. Does anybody here think that using a passwordless solution is actually worse or is actually less secure than having a password? Can anybody think that? All right. A few of you? All right. Well, the answer to that question, actually, no, is not less secure. Yeah, sorry about that. And, yeah, well, and actually, that is my whole talk. Thanks for coming here today. Thank you. No, no, no. Sorry, that was a terrible joke. I'm sorry about that. No, this is the agenda that we're going to be talking about today. First of all, some background on why am I giving this talk. What is passwordless for those of you who are not familiar with this paradigm? And then we're going to dive into what are the actual issues with passwordless implementations. And at the end, we're going to have some recommendations for all of you, developers, pen testers, and enterprises. So to set up the expectations, this talk is about, this is a brief introduction into passwordless. This is not a full talk on passwordless. We're going to be talking about vulnerabilities in a passwordless implementation, specifically a web application. Passwordless can be used in other types of applications, but these vulnerabilities are related to passwordless in web applications. And these issues were identified in a particular passwordless product that shall remain nameless, but no, it's actually my employer. But these vulnerabilities apply to any application that is using passwordless. So this is not specific to a product. It applies to any application that is using passwordless. So what this talk is not about, we're not going to be disclosing any new attacks. I'm not dropping any ODAs today. I'm not doing a full talk on passwordless here. We're not going to be talking about how to break cryptography. Passwordless, one of the implementations uses public key cryptography, so we're not going to be talking about that today. And yeah, why am I doing this today, right? So basically, I think that nobody's talking about passwordless vulnerabilities. The vendors right now and the whole industry is moving away from passwords slowly, but it's moving away from passwords to the passwordless paradigm. But nobody's actually talking about it. And a lot of big players such as Microsoft, Google, Apple, they all are pushing for passwordless, but they are not talking about their issues, right? I actually went to bolddb.com and searched for passwordless, and I get 0 results. None of it. Some of the stuff that I'm going to be talking about today is already public, and they are not there. Out of curiosity, not to throw shade to any of the competitors, but I went ahead and I went to their websites looking for some advisory page, something related to vulnerabilities, and I didn't find anything. So in short, nobody's talking about this. Just a couple of weeks ago, when I was getting ready for this talk, I went ahead and looked for passkeys on Google. And as you can see here, we have many examples of companies already implementing passwordless. We have, well, they are implementing passkeys, which is a way of doing passwordless. And we're going to be talking about that. So we have 1Password. We have TikTok that is now using passkeys. We have GitHub. We have PayPal. We have Apple ID. And this was just a couple weeks ago. And if you go right now and search for passkeys, you're probably going to find more examples like this. So a lot of companies are going passwordless. And but how secure are they? That is the question. So what is passwordless? For those of you who are not familiar with this paradigm or are not really sure what I'm talking about, passwordless essentially means not using a password. In short, that's it basically. And no, that's really not a joke. That is actually what it means. One of the most traditional implementations is using public key cryptography, but there are more. And essentially, well, if you're not familiar with public key cryptography, essentially it creates a key pair, one public key and one private key. The public key stays in the server, the private key stays with you or your device, and then the application sends a challenge that you have to sign with your private key, and only you can sign that challenge. It's very secure. A lot of cryptography works that way nowadays, so this is how the most common ways of implementing passwordless nowadays. A couple of quick mentions. When you are using a password manager, that is not passwordless. And I mentioned this because I saw a post the other day about somebody telling, oh, go passwordless, use a password manager. And that is obviously not passwordless. They're just, well, you're storing your passwords somewhere else. So that is not passwordless. When you have two-factor authentication, that is also not passwordless because you are providing your username and password, and then you are providing an additional factor. And lastly, when you have one-time password, where obviously the name suggests you have a password that is valid only once, but it's still a password. So in short, passwordless means using no passwords. And these are some of the ways that you can actually implement passwordless. Let's talk about them real quick. One of the simplest ways to implement passwordless is using a magic link. For those of you who are not familiar with magic links, essentially a website sends you a link to your email, you click it, and you authenticate to that website. That's it. And I think that's why it's called magic link, because it looks like magic. You don't have to provide a username, you don't have to provide a password, you simply click on a link and you're in. That is actually pretty practical, but it has some disadvantages, such as if the attacker knows your, if the attacker has access to your email, well, they own your accounts, right? These magic links can be delivered using email, SMS, and basically any way that you can reach your user. The second part of the way to implement passwordless is using security keys, such as these ones. So these are YubiKeys. These are physical security keys. Anybody here already uses YubiKeys or security keys? Oh, perfect. That's amazing. So this is actually my preferred way to implement passwordless. But as you know, this could be quite expensive, especially if you are a big company. For instance, let's say that you are Facebook and you want to deploy passwordless to all of your users. I don't know how many users they have, probably 1 billion, I don't know. So can you imagine just trying to purchase YubiKeys for your 1 million users? That's not going to scale. And lastly, we have biometrics, which work in the same way, well, very similar to security keys. They create a public key pair, and you have your own private key, and that is unlocked using your biometrics. So this is a very good alternative to security keys. Everybody has a smartphone nowadays, and they can use that smartphone as a way to provide passwordless access using your biometrics. This is just an example of how Slack does passwordless. Essentially, you go to the login, you provide your email, and they are going to send you an email with a code, and you provide that code, and you don't have to provide any passwords at all. That is another way to implement passwordless. All right, but now we have FIDO. I mean, we see that we have several ways to implement passwordless, but we really didn't have a standard until recently. So everybody was doing it on their own way. So this is why the FIDO Alliance exists. The FIDO Alliance basically is an organization that is in charge of maintaining a specification for the FIDO protocol. FIDO means Fast Identity Online. So essentially, it has two main components. One of them is Web Authent, which is short for web authentication. It's a set of APIs that browsers can use to communicate between these authenticators and web applications. And the other component is the client to authentication protocol, which we're not going to be talking about today. We're going to be talking heavily about Web Authent today. So again, this is a set of APIs that the browser uses to communicate between the authenticators, which can be security keys or fingerprint, and web applications. Also, I wanted to mention passkeys. When I say passkeys, when I say security keys, when I say passwordless, and when I say biometrics, I am referring to the same thing. They are not the same thing. I am simplifying things, but for the purposes of this talk, it's all the same, and all these vulnerabilities are going to apply to passkeys, security keys, biometrics, and any other authenticator. And just to double down on WebAuthn, again, this is a set of APIs, JavaScript APIs, that allow your browser to communicate with authenticators and web application or relying party. Authenticators can be anything such as physical security key, Touch ID on your Mac, Windows Hello on your Windows computer, and biometrics on your mobile devices. So this is an example of what using WebAuthn looks like. On the left, you have a YubiKey. In the middle, you have fingerprint in Chrome. And lastly, a fingerprint on an iPhone. So if you previously have seen something like this, you are already using, well, not passwordless, but WebAuthn. All right, so why going passwordless? I found this fine gentleman online, which probably hates passwords as much as we do. So, well, we are at PasswordsCon, right? Probably a lot of you know that everything about passwords suck. So, you know, storing them, protecting them, hashing them. Yeah, you have to use an algorithm that is slow enough to stop attackers, but not slow enough to bother users. Well, it is a problem, right? When you go passwordless, you don't have any more passwords to remember. You don't have any more passwords to protect. You don't have to worry about ineffective complexity factors. And you don't have to worry about people don't knowing their own passwords. The last time that I got my wife a phone, I was helping her trying to set up her phone, right? And I asked her, hey, can you log into your Gmail account so we can set up your phone? And she was like, I don't know my password. I'm like, what do you mean you don't know your password? And she doesn't. She logged into the Gmail account once and she forgot about it. And the same thing happened with my parents. When I got them new phones, they didn't know their passwords. So, they were all able to reset them, but I mean, this is an issue. A lot of people don't know their own passwords. Passwordless is is faster than traditional MFA. It protects against phishing. For those of you who are not familiar with this, essentially when you register a security key, that security key is registered to a specific website. So if somebody was trying to phish me and they send me a fake link for my Microsoft account, even if I were able to fall for that trick and I plug in my YubiKey, it's not going to work because that security key or that FIDO credential is only linked to a specific website. So that is not going to work. And lastly, we don't have any more password resets, we don't have any dictionary attacks, etc., etc. So all good things when not using passwords. So, thanks for going through that. I needed to provide you some background for those of you who were not familiar with passwordless. Now let's talk about this. So, passwordless has a few misconceptions. Like we just saw, a lot of people may think that passwordless is less secure. Basically, you don't have a password, right? So what is protecting my account if I don't have a password? No password means no security. That is not the case. We're going to see it. And for instance, I have heard from people who think that somebody else can unlock their phone using a photo or maybe their twin, for people who have twins. And also people thinking that fingerprint can be cloned. Those are general misconceptions that I have heard from people really not working in tech. And also we have stolen or lost device issues. So basically, if you lose your device, an attacker is going to be able to authenticate to a website using your device. I think that if an attacker steals your phone and they are able to bypass your biometric authentication, you probably have bigger things to worry about than they being able to log into your Facebook account, for instance. And lastly, this one is actually true. If you lose your device, you're going to lose access to your account. So this is why you must have either a backup account, a backup device, or a way to recover that account. So that's actually a valid concern. All right, so now let's talk about real vulnerabilities in passwordless implementations. Finally. All right. So this is the first issue, and I, on purpose, didn't provide the title because I didn't want to give away all the fun in the beginning. So this is directly from the WebAuthn documentation. So if you go to that website, you're going to see that basically you need to provide a user object. Essentially, that user object has a name, a display name, and an ID. This is required for any whenever you are trying to authenticate or whenever you are trying to add a new authenticator to an account. Just give me 1 second. Oops, sorry. Oops. Excuse me. Just give me 1 second. There we go. Sorry about that. All right. So yeah, I was saying that you need to provide a user object when you are adding a new device. This is expected because you need to map that specific device to a user, right? So this is all in the documentation for WebAuthn. And then I went ahead and looked for some examples of those specific implementations. The first one is from our friends at Yubico. Essentially, Duo Security. And you can find the same. They are saying that you need to provide a user object, and that user object contains an ID, a name, and a display name. This is directly from the documentation. Again, this is expected. This is the way that WebAuthn works. One more example. We can find the same thing. You need to provide a user object. It has an ID, a name, and a display name. This is JavaScript code, by the way. This is the WebAuthn API. Lastly, I went for the Yubico documentation. In order to add a new YubiKey, you have to do the same because YubiKeys are also a FIDO2 credential and are also using WebAuthn. So you need to provide a name, a display name, and an ID. All right, so that's part of the expected data that WebAuthn is expecting, right? Also for passkeys, as I mentioned, passkeys are also a FIDO2 credential. Passkeys are also using WebAuthn, so you also have to provide an ID, a name, and a display name. With all that being said, this is a real implementation of passwordless solution. For those of you who are doing pen tests, you know that this is burp. This is basically an HTTP intercepting proxy. It's allowing us to tamper with all of the data that the browser is sending to the server. If you take a closer look, you can see that the application is sending a username and a display name as part of the specification. Quick question here for my pen tester friends. What do you think it could happen if we try to tamper that username to another email, let's say the CEO's email? Any guesses? No? Well, the specification doesn't actually say it, but in this particular specification, if I tamper with that value, instead of adding a new device to my account, I was able to add a device to a different account. So essentially, by doing this, you could essentially take over any account in the company that you wanted. Just by adding a new device, you could impersonate any user in the system. And remember that we are doing passwordless here, so we don't have any other way to authenticate. Simply by sending this request, you can actually take over any account that you like. This actually has CVE. You can go ahead and look for more details. But let's talk about it. All right, so this application was following the specification to the letter. It was doing everything that the documentation says. There wasn't anything wrong with it. One thing I want to mention is that the documentation doesn't say that you don't have to trust this data. It may sound obvious to us security people, but this is not obvious to the people who are implementing WebAuthn. Or at least if it's documented, I couldn't find it. So that actually makes me think, I mean, how many other applications are there that are just following the WebAuthn documentation and they are not providing that additional check? Essentially, if you wanted, actually, if you like to remove that data from the request, it's not going to work because WebAuthn is expecting that data. So yeah, so it's leaving the developers to know. I mean, they are on their own to implement this additional check because nobody's telling them that they have to do this, right? So this actually is for me. I should reach out to the FIDO Alliance and ask them, hey, why are you not pointing this out? Why are you not documenting this? Or if you are, where is it? Because it's not obvious, and nobody, I mean, at least this implementation was not doing it. All right. Moving on to magic links. If you remember, magic links are simply just a way to users to authenticate, right? They receive a link, they click it, they are in. This is a way to implement passwordless. But one thing I like to mention is that web applications are usually just as vulnerable as they are flexible. And what I mean by that is that you can do pretty much anything that you want with web applications. If you want to read a username from the headers, you can do that. If you want to read a username from the cookies, you can do it. I'm not saying that you should, but you could. So this is a problem with because you are letting your developers do whatever they want, right? So this is a simplified example. This application had a way to authenticate users using a link, something like this. Essentially, the application was providing a token, the user click it, and they are in. However, this particular application had two different user roles, one for users, one for admins. They were both able to authenticate using a magic link. However, we can do some forced browsing. And for instance, if we try, this is an example, of course, but if we added the word admin, the token for the user was good for the admin. And let's say that you got a token as a user, you simply change the link to and add the word admin, and you become an admin. Just like that. This also has a CVE. You can go ahead and look for it if you want more details. So let's talk about this. The token that the application was using was actually quite secure. I mean, it was using good cryptography. It was really long. I mean, it was being created using secure functions. The token was expiring as soon as you click it, and even if you didn't click it, the token was being expired after some time. So the magic link implementation didn't have any flaws, apparently. But as you know, developers need to be sure to protect every single endpoint. They need to be able to verify every single input field, and attackers only need to find one endpoint that you missed. And this is what happened here. All right, moving on to number 3. This is actually another account takeover using parameter tampering. It's very similar to the previous one. And again, web applications are very flexible. When we're dealing with passwordless authentication, it's not one single request. For instance, when you are talking about username and password, usually the username and the password are sent in a single request, right? So, and that's it. But this is not the case when we're talking about passwordless. Usually needs several requests. You need to sign a challenge, then you need to sign it, then the application needs to verify it. Really, it needs a lot of requests. And in this particular case, the application was doing a lot of validations, but again, they missed just one. So the attacker was able to provide a valid authentication for the user, but authenticated as a different user instead. This also has a CVE, and you can go ahead and look at if you need more details. All right, let's talk about one more. This one is about account creation. Again, web applications are very flexible. You can do pretty much what you want with them. And this time we were talking about a demo application. Companies sometimes provide demo applications so they can teach their customers how to implement passwordless or how to implement anything else, right? In this case, this particular vendor was using a demo application, but in the user creation flow, the application was not checking whether the user existed or not. So essentially what happened is that you went to the login page, you tried to register, you provide a username, and the application wasn't checking if it existed or not. And essentially, since we're doing a FIDO authentication, you were adding a device to an account. So from a passwordless standpoint, it is the same as adding an authenticator to an existing account or to a new account, because you are simply adding a new device, right? So what happened is what you were able to add new devices to any existing accounts, and you were able to take over those accounts. Again, this is a demo application, but still I think it's pretty good to know that we should be doing all of these validations. And lastly, the always top 10. We have to remember that we are talking about web applications here. So we don't have to, we must not forget about doing the basic validations that any other web application needs to happen, right? We have to do input validation, we need to do security checks in every single endpoint, and so forth and so on. All right. So now let's talk about some recommendations. For developers, if you already have a secure SDLC, I think it's really good that you have it. If you don't, you should implement one. What I mean by that is that you should have some form of security testing in place, maybe some code scanning, some dependency check, and all of those things that are very good to increase the security of your application. Also, you should do some testing, and then more testing, and then more testing. I mentioned this because all of the issues that we talk about, they were found by humans. There is simply no way that a tool can find these issues. And if there is, please let me know, because I don't know of any tool that can do this. Probably not even AI. So the best way to find the security vulnerabilities is by having testing done by humans. Also, embrace testing for customers. A lot of times, companies don't want to allow their customers to do pen tests because they think they're going to find issues and you're going to have to fix them. That sometimes is true, but I mean, I think that's best because you can find those issues before an adversary does, or before most customers do, or before you have a leak. So while it's true that this is going to mean more work if you have issues, I think it's best to do it because otherwise it's best to fix it before everybody knows, and that way you're going to prevent breaches and security incidents. For enterprises, if you're thinking of implementing passwordless, you are thinking about doing it in-house versus a vendor. If you're thinking about using a vendor, I think it's really important to hold those vendors accountable. It's important to realize, how many times are they getting testing? Are they just doing one pen test a year for compliance? Are they doing multiple rounds of testing? Do they have a bug bounty program? Are they testing new features? Do they have a public CVE program? So I think these questions can actually make it apparent if that company is actually doing something about security, or even maybe they don't even have a security program. So yeah, this is for all the enterprises. For pen testers, yeah, actually, when I was first testing passwordless solution, I was kind of intimidated by it. I was thinking, well, this is using public key cryptography, right? I'm not a cryptography. I'm not going to be able to find any issues here, right? Well, no, the truth is that at the end of the day, these are just web applications. They have the same issues as any other web application. My personal recommendation for any pen tester is going to be just go for parameter tampering. This is where you're going to find the most issues, and also unauthenticated APIs. So yeah, all of the issues that we talked about before, they are related to web applications. So basically, all the same things that you're doing are going to work in a passwordless application. And my recommendation would be not to spend too much time on trying to break the cryptography. I mean, if you can, go for it. But it's probably going to be a lot of time, and you're not going to get any results there. For users, actually embrace the future. I mean, I talk about how passwordless can have issues, but actually it's way more secure. Whenever you are presented with the option to use passwordless, you should do it. I mean, I think that passwords have way more issues than passwordless, and as you can see here, whenever an issue is found, it's quickly fixed. So passwordless is a very secure option. All right, so I think I went really, really fast because that's it. So that means we have a lot of time for questions if you have them. If not, thanks a lot for being here, and thanks a lot for your time. Thank you.
Aldo, in the example you gave of adding a device, is there a way that we as the user can protect it? I mean, what do we do?
Not really. The question was if you as users can protect yourselves against somebody else adding a device. Really, there is no way you can do that. The application is the one that has to be providing that additional check to make sure that the user who is adding the device is the one that owns that account. So really, as users, we don't have any defense.
Do you have any recommended pattern? Oh, there you go. Do you have any recommended patterns for account recovery? What we find, I guess, when we see most of the implementations we see leave old school methods in place for account recovery. So it'll be like you still have a password if you need to recover your account, or use TOTP or something like that, or use a phone number. And we find that most vendors aren't fully disabling legacy security in favor of passwordless. So I'm wondering if you have any fully passwordless account recovery mechanisms.
Sure. Well, this is not a blog. I mean, this is, well, we do have, in my vendor, we do have a way to do that. So essentially what it does is that we are providing a way to verify the identity of the user. Essentially, we have a specific website that you can go. You type your username, and then we do an identity verification. Right now, we're using it by using essentially, it's like a meeting. I mean, I can describe it better by showing a demo. But essentially, we do have a way to do this. It verifies your identity. It connects you with your manager, and basically, it can do face verification or phone verification. That's up to the manager. And once they have verified that you are the person who owns that account, they send you a magic link, and you can add a new device. More questions? No? All right. All right, well, thanks for being here. Feel free to, I didn't have a Twitter, but feel free to add me on LinkedIn if you like. Feel free to reach out to me if you have any more questions, and thanks again for being here. Thank you. That was too fast.
No, it's all good. And thank you, everyone, for being here. 2 o'clock, we have a talk with Mackenzie Jackson on our secret safe and how mobile applications are leaking millions of credentials, which would be pretty good. And then hopefully, if we all follow this, all same with Aldo here, then we won't have a conference next year here for passwords. So we'll all be passwordless. Thank you.
Yeah, like,
But everything was clear. It's good to see that passwordless.
some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, but I don't wanna jinx it, baby. Let's not get ahead of my time. Oh, but I don't wanna miss you, baby. So I stand up and speak my mind. Oh. Baby, you give me ice and fire. You're chilling in the rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, oh, of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, well, I don't wanna jinx it, baby. Can't twist myself at the spine. Don't wanna overthink it, baby. It's just twist your body and mine. Baby, you give me ice and fire. You're giving me wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, but I don't wanna jinx it, baby. Let's not get ahead of my time. Oh, but I don't wanna miss you, baby. So I stand up and speak just my mind. Oh. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, oh, You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight eye. You whip up my appetite. Don't leave me here high and dry. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight eye. You whip up my appetite. Don't leave me here high and dry. Oh, oh, whip up my appetite. Don't leave me here high and dry. Oh, well, I don't wanna jinx it, baby, and twist myself at the spine. Don't wanna overthink it, baby. It's just twist your body and mine. Baby, you give me ice and fire. You're giving me wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, but I don't wanna jinx it, baby. Let's not get ahead of my time. Oh, but I don't wanna miss you, baby. So I stand up and speak my mind. Oh. Baby, you give me ice and fire. You're chilling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, oh, up my appetite. Don't leave me here high and dry. Oh, well, I don't wanna jinx it, baby, and twist myself at the spine. Don't wanna overthink it, baby. It's just twist your body and mine. Baby, you give me ice and fire. You're giving me wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, but I don't wanna jinx it, baby. Let's not get ahead of my time. Oh, but I don't wanna miss you, baby. So I stand up and speak just my mind. Oh. Baby, you give me ice and fire. You're chilling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, 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 oh,
Good afternoon, everybody, and welcome to BSides Las Vegas. We are here for the PasswordsCon. Appreciate you coming to hear from Mackenzie Jackson, who's going to be talking about, are your secrets safe? No, they're not. We know they're not. Finding millions of credentials and mobile apps. Just a few things we want to say. Thank you to our sponsors, especially the diamond sponsors, Adobe, and our gold Prisma, Cloud, Blue Coat, Toyota, and Conductor One. It's their support along with yours that makes this what it is. Cell phones, please turn them off. We don't want to hear it. If somebody's calling, it better be God. Also, if you have any questions, save them for the end because he doesn't want to be interrupted. So, on that note, let's get started. Mackenzie, all yours.
Thank you. That introduction is probably like going to be the highlight of this talk. So, but thank you all for coming here. I'm really excited to be presenting at BSides Las Vegas. This has been one of my goals to be able to present at this conference. I have a funny story before we start. Last year I was a volunteer and I was on the registration desk, and I was chatting to the people on the registration desk to me, and I was with 3 other CISOs. So if CISOs are the people that are volunteering here, I'm kind of terrified to know what the audience members are, but I'm really happy to be presenting here. So my name is Mackenzie. A little bit about me before we get started. I'm from Aotearoa, New Zealand, but today I live in the Netherlands, and I work for a French company, so there's a range of countries there. You can find me anywhere on social media at the handle @AdvocateMac. And I also am the host of the Security Repo podcast. It's my mum's favorite podcast. She hasn't missed an episode, and it'd be really great. She recommends it to you. If you live dangerously, there's a QR code. Scan at your own risk to take you to that. All right, we'll get into the topic. So what we're going to talk about in this session is really discovering secrets. So we're going to talk initially about kind of secrets. Now we're in PasswordsCon, so I don't need to spend too much time about this, why they're a problem. Then we're going to look at discovering secrets in source code. I'm not going to spend too much time about this because the presentation after me is actually going to go deeper into it, but this is kind of what kicked off my interest in mobile apps specifically. And then we're going to talk about discovering secrets in these compiled applications, downloading them and finding them. Finally, we'll talk a little bit about how to securely store secrets, and then we'll have a go into some questions. All right, so just quickly, I'm sure everyone here is familiar, but just in case, to get everyone on the same page, what do I mean when I'm talking about secrets? So I'm talking about digital authentication credentials. These can be things like API keys, security certificates, credential peers, and the key difference here is that these are made to be used programmatically and generally machine to machine, right? So I have yet to successfully memorize an API key, and use it. These are meant to be used by our systems to authenticate themselves. Now, why that's important is because when things are made to be used programmatically, they often end up hard-coded or in the wrong place because humans still handle them even though machines use them. And so that's really what we're going to be talking about now is identifying where they've kind of leaked out of where they're meant to be, how we can identify them and how we can use them. So why do secrets exist? A question I ask myself every day. But if we take just a kind of a modern application, a mobile application, secrets are used because of a shift in how we build our software. Our applications aren't monoliths that do everything. We connect to lots of different services. So, the easy one to talk about is something like Okta, where are you going to build your own authentication, or do you outsource that to a service that is doing just that? Or do you use Algolia for search? Do you do your own credit card processing, or do you outsource that to Stripe, especially if you're trying to get around the 30% fees that the app stores charge? But applications quickly end up compiled of these different services, and they all communicate with secrets. But it doesn't stop there because we have to have back-end infrastructure, we have to have testing, we have code that we need to deal with. So then our infrastructure also uses lots of these secrets. Now our mobile application needs to talk to these as well, potentially through the back end, but they still exist as secrets. And then it doesn't stop there because we want to monitor it. We need to have monitoring of it. Perhaps we want to have crash logs being sent somewhere from the app. So we need secrets to be able to do that and get information. And these are all potential access points, and we haven't even talked about the microservices that we create. So your simple little mobile application very quickly turns into a collection of all these different services, all doing different things, and we need to authenticate with each of them. And we do this through secrets. But every single one of these points, if I'm an attacker, this is a potential entry. If I can gain access to something, even if it doesn't seem that interesting, you may not think that me getting access to a Slack channel is important. I'm going to talk about that exact example later. But as an attacker, I can do lots of different things to be able to abuse that and leverage that to elevate my privileges and gain access into lots of different areas. All right, so how should secrets be stored? This is going to be a very, very simplistic example. But just before we get into all the bad things that happen, we'll talk about how it's meant to happen. So we have our front-facing applications. For Android, this is an APK. For Apple, this is an IPA. We shouldn't have any secrets in these. Now, unsurprisingly, we're going to discover that there's lots of secrets in here. But we really shouldn't. We should have our secrets stored in our back end, perhaps through a secrets manager, or just in our cloud infrastructure, they often have secrets manager. We want them loaded into our local memory. And that's what communicates with the third-party services and sends our data securely to our application. This is how it should be set up. But often, lots of things change. People cut corners, or they feel like they're doing it more efficiently, or they'll come up with lots of arguments as to why the insecure way they're doing it is actually secure. I'll talk through some of them as we go through. But this is really how it should be done, but it's not often how it is done in practice. So let's get into the first part of this, finding secrets in source code. As I said, I'm not going to go too deep into this. If you're really interested to talk after me, we'll go deeper. But I want to address this because this is really what made me start thinking about secrets inside source code, inside mobile applications, based on some initial research I was doing in source code. So to give an idea, the State of Secret Sprawl is a report that GitGuardian, the company I work for, releases every year. And one of the things that we do is we monitor public code repositories to try and identify if secrets are leaked in there. Now, the biggest one is obviously GitHub. So GitHub has huge amounts of information. There was more than 1 billion commits or contributions made to public repositories in GitHub last year. And we scanned every single one of those to try and identify how many secrets are out there in public repositories. So last year we found 10 million. So 10 million secrets, and we validate a lot of these. So this isn't 10 million random high entropy strings that look like secrets, but are just URLs or unique identifiers. No, this is 10 million secrets that we're fairly confident are true positives. So this is a huge amount of information. If you want to win some candy, if you remember this number for the next presentation, it's going to come up. But we looked at the file extensions that we had, and I got an interest because we were going through lots of information, and I wondered, how many mobile applications, how many of these would actually concern mobile applications? Because I had heard a lot about mobile applications being breached, passwords being found in there. So I wanted to use this research and this information to get a deeper understanding of how these mobile applications are actually using secrets. Now, truth be told, I'm not a mobile dev. I've driven into this topic from a security perspective and learned along the way. But there's a bunch of files that really are specific to mobile applications that kept coming up in our research. So if we look at some of them, the dot properties, now obviously these aren't only exclusive to mobile applications, but ones that when looking into, they're frequently related to mobile applications. XML files were often related to mobile applications, and the plist file, which is nearly always related to iOS development. And so when I had a look into these, I did some further research to find out how many of these contain secrets and what are some of the file names that we had. So if we're looking just at Android applications, the main one that we were discovering secrets in was the Android manifest.xml. We found 23,000, nearly 24,000 secrets in this one XML file. Other ones as well, strings.xml was a big one that was related to Android developments. There's a long list of these files that we can go down. Here are some of them. And just the last one, I always like to add in a funny one. API key.properties. Feels like something that probably shouldn't be in a public Git repository. Definitely not. But we still find 65 of these keys being leaked. So this is interesting. We found similar results when we looked at iOS, Android application specific. The main one that we found was the Google services-info.plist. This is a file that's generally always related to Google services, and namely Firebase. Now, by default, this shouldn't really be that sensitive because it should only contain your Firebase ID, which might be useful for attacker, but not really. But then people started doing really weird things. They started adding secret keys into this file as well. I guess maybe it's handy to have both of them together. And we started seeing lots of weird secrets inside these, and also lots of other ones. And again, API keys.plist feels like something that shouldn't be in a Git repository, but often is. So when we looked at all of these files, it really got me thinking is to, if these are the types of files that are containing secrets in public Git repositories, then it really has to be that in private Git repositories, the problem is much worse. And if this is the flow, that means that the application at the end is going to have those secrets in it. So looking at this source code really got me thinking that ultimately these secrets are going to end up in the mobile application. And so that's what kind of started me off for this. First, I want to talk about exploiting secrets in these public source code. I'm not going to spend too long about it, but just bring it up. How would an attacker that's specifically looking at exploiting a mobile application be able to discover these types of files in public places like GitHub? So generally when secrets leak for applications, they don't leak in an official repository. They leak in a repository attached to an employee that maybe accidentally leaked something or is starting their own project that doesn't realize there's secrets in the history that belong to their organization. But there's a couple of ways. So firstly, this is kind of my least favorite way, but I'll talk about it briefly because it's the easiest. You can just use the GitHub search feature, what we call GitHub dorking. So we know that the Android manifest.xml has lots of files. So if I'm looking to exploit an Android application, I might narrow this down to specific keywords. I'm looking for an API key. And there's lots of different types of these dorks that we could do. This isn't a great method. The reason why most of the secrets that you find in source code are in the Git history. When you're using the GitHub search feature, it doesn't search the history. It just searches the top level or the latest version on the main branch. So there's a much better way that we can programmatically try and find these keys inside mobile applications, and that's using the GitHub API. So we have this events API. If anyone can go to it, you can do it on your phone right now. It's api.github.com/events. Everything that happens publicly on GitHub is on this ledger, is on this API. So what we can do is we can start using the public events and the push events to try and find code or code for things that shouldn't be in GitHub. For instance, narrowing it down to the Android manifest and strings. This is a huge amount of information to digest, but if you're trying to exploit a mobile application, if you know that it's going to be an Android manifest XML or strings.xml that's going to give you your most amount of prizes, then we can narrow it down, and all of a sudden this fire hose starts becoming digestible. So this is really some of the ways that we can do it. And also, if I'm trying to exploit a specific mobile application, then what I might do is I might discover what employees are working for that, if they have personal GitHub accounts, and then abusing this API to try and find files that relate to this specifically for them. But that's enough about source code. All of this sent me off down this journey of trying to figure out how mobile applications can be breached. Can we find the secrets inside of them? And exactly how do we go about doing that? All right, so let's get into that. So firstly, on the Play Store, this is probably something of what you see. And we look at these and we're trying to figure out what are mobile applications in their raw form. How can you download it? So most people make the mistake that non-human readable means secure. So when we submit an APK file to the Android Play Store or an IPA file to the Apple Play Store, we all think that, okay, or a lot of people seem to think that this is some kind of black box. It's not human readable. You can't really extract any information from it from just that file. So that means it must be secure. It's totally unhackable. But that's absolutely wrong with so many things like this. Same with packages, same with containers. So what we started doing is first step is to turn these files back into something that's human readable. And it's very easy. So there's two types of files when we're looking at mobile applications. So the first file that we have is the IPA from Apple, and the second file is the .apk from Android. And so what are these? These are basically glorified zip folders that we can use to extract the source code. And once we've extracted the source code from them, then we can start looking into them to try and find any sensitive information that may be in here. So how do we actually find these secrets? So I'm going to run through quickly. If you guys all say a prayer to the demo gods, I'm going to hopefully this will all work. But the first thing that I want to do is I just want to show you how easy it is to extract these files. So here I have two. I have my Android app.apk and my iOS app.ipa. These are real files that I've downloaded from the respective Play stores or App Store. So that I've kind of chosen at random, but I've removed their name because there's some sensitive information inside here that I don't want to get in trouble for disclosing. Just give me a minute. Okay, so the first step is we need to try and get this back to something that's human readable. So to do this, well, I guess the first step is we need to download it. So you'll notice that you can't download these on your computer. You need to use some kind of mirror or some kind of tool. So there's an easy one for Android applications called Gplay Downloader. So I use that to download the application. Then I'm going to use a different tool called JDAC, which is a decompiler to get this back to its original form. So just to show you what that looks like. It's just going to take a few seconds, and then that's going to be able to spit out and take me back to the source code, because once you have the source code, then really you can actually start doing some interesting things and looking for some files. So now that we've done that, let's open up what we've just created here. So this here is the source code of the application that we've downloaded. So here you'll see the Android manifest. We've talked about this file. So this is where I can already start to find some interesting information and go through in here. And also we know that there's some other files very interesting, like the strings.xml, which we can find in various files here to try and get information about and see if there's any strings hidden in there. The problem with this is that these are really massive files, and buried under all of this may be something interesting, maybe. And hackers, or at least I am, very lazy, so we're always going to find a better way to do it. So what I want to do now is just show you what I would do in real life. Is just scan this file for secrets. So I'm using a tool called GG Shield. Fair warning, this is a tool that GitGuardian, my employee, creates, so I'm wildly biased as to why I use this, but it's definitely the best, totally. Whenever I'm on stage, I forget how to spell the most basic words. I told you. I was just checking to see if everyone's awake, you know, making sure everyone's paying attention. It feels wrong, but let's give it a go. All right, so this is going to take just a little bit of time. Oh. Huh? Okay, this is going to take just a little bit of time to scan, so I want to go back to something else. So I've easily shown you how to extract the the Android application. Now, I do want to warn you, the iOS application is much more complicated, so I hope you pay close attention and take lots of notes as to how we can do this. So what we need to do in our Android application is we take here our .ipa and we change this to .zip. And we have a look in here. And we have our source code from this. So hopefully you took lots of notes on how to do that. I can't do it again. But yeah, that's really how interesting. So when I mentioned that these are glorified zip folders, particularly for the iOS version, I'm like absolutely dead serious. These are literally glorified zip folders. So now that we have the source code, we've extracted that, it's really easy. If there's a hard-coded secret in your source code, it's going to end up in your application. And we can easily extract it using simple tools, or in the case of iOS, not even using any tools at all. So I'll try and see what my scanning is doing. We'll wait a little bit. These are all, okay, we're all done. So we'll go up to the top, and these are some of the secrets that we've found. I want to stress again, this is a real application downloaded from the Play Store. But I have hidden all the secrets, so you can't do anything malicious with it. So the first secret that we sent, we've got some valid Google API keys. These can be interesting. These are in a Java file so that we know that these are hard-coded. When we decompile things, obviously we don't get the original names. We lose a lot of information. It's human readable, but it's, we don't have everything that was there, but we can see that we have these Google API keys. Here we have something very, and we also can see that these are valid. So we've checked to see if these are valid, so we can use these. We also have Google OAuth keys. We can't check these automatically, but these can be extremely sensitive, depending on the setup. We have Facebook app keys. And we also said we have here some Slack webhooks, and these are valid. I find Slack webhooks literally everywhere because people kind of assume that they're not that sensitive. And in some ways that they aren't. So what does this Slack hook allow me to do? This Slack hook allows me to be able to post information into a private Slack channel. What's the use case for this? I'm going to assume probably that this may be some error or debug logging that's being sent. When something happens, it kind of gets sent, a crash log gets sent to a Slack channel. That's interesting. But me, as someone that's malicious, I can do lots of things. Like I can create some clever phishing messages in there to say that, hey, this integration has disconnected, please re-log in, or something like that. Go to a mirror of Slack and get people to give me their credentials. Now, it doesn't always work, but it works a lot of the time. Because how else would I have that Slack webhook, right? You've broken down some barrier of trust. I'm not a Nigerian prince emailing you. I'm your own system telling you need to update your information. So this is this is kind of what we get, and it keeps going down some more webhooks in different areas. And we have a couple in. I'm trying to find this interesting files here. And here we have the strings XML, so this is obviously what we found. So what I found originally on GitHub that led me down this path to kind of wonder if this is interesting, translates into the app. People were putting secrets and strings.xml and putting it into public Git repositories. Then I wondered, hey, does that mean they're going to be in the app? Turns out it exactly means that they're going to be in the app, as we can see right here. So this is just the process that I used for Android. I downloaded it with a gplay, I decompiled it with JDAX, and then I scanned it with ggshield. So, this is very simple. There's other tools out there too, and this isn't that complicated. Honestly, I'd say that this is definitely at the level of a script kiddie, or even below, where you can just go through this. You can pipe these all together and just download apps all day long and try and find sensitive information. I'm going to talk about when we've done that and what we've found later on. But we definitely, this is my backup demo just in case it failed. And the similar process for Apple apps. I used a tool called IPA tool to download it. Apple won't let you download anything unless it's on a mobile. So what this tool does is basically trick it into thinking it's on a mobile. It uses your Apple ID and you can download it there. There's also lots of mirrors online where you can just download files. You just change the extension. You don't even need a tool to decompile it, and then you scan it with ggshield. So again, really simple, about the level of a script kiddie to be able to do this. So we're not talking about highly sophisticated attackers. If we were, I probably wouldn't be presenting, to be honest. So let's talk about when this breach, a breach that's actually happened. So this one here is from Jason Haddock. This is a story that he told on the Security Repo podcast. That's a great episode if you want to check out. And this is about when he was doing a penetration test on a bank application. So if you don't know Jason, he's an absolute legend in the field. He's been a very highly regarded penetration tester himself. He has a checkered past, which you can hear about on the Darknet Diaries episode with him. But this is an interesting example to show that this happens in real life. So there was a bank that had a mobile application, and Jason was doing a penetration test and downloaded that application and started playing around with it. This particular bank application had a functionality. So apparently in America, United States, you guys still use checks. That baffles the rest of us. But one of the features of this was that you could take a picture of your check and cache it, all in the app. So when Jason decompiled this, he looked at how this and found that actually these images were being stored unencrypted in the mobile device. So he kind of figured, well, if that's being stored unencrypted somewhere, that means it's being sent unencrypted somewhere, and if I can get access to that, that would be great. So he found that there was a S3 bucket that these were being sent to inside the app. And again, we're talking about a tier 1 bank here. We're not talking about Bob's Financials. We're talking about a bank that I can't disclose because he didn't disclose to me, which is probably a good call. And then in that, there was a hard-coded secret for that Amazon S3 bucket. And then with that, Jason was able to access that Amazon S3 bucket and find 10,000 images of unencrypted images of checks from this. So this isn't something that just happens to small applications. This is something that's widespread, where secrets often end up inside our mobile applications because we honestly think that we don't understand how easy it is to do it. And when you're putting something in an APK online, you're putting up your source code. You should absolutely remember that. So you want to make sure that your source code is consider it open source and expect the same security measures from that. So this is just a real life example of when this has happened out in the world. So what about other examples of discovering secrets on the Play Store? So there's actually a few research that have been done on this. ZNet published that there was 12,000 Android apps that they found that contained secrets. And Cyber News last year did a great study on that. And I'm going to shamelessly steal their information and talk about that. I did a webinar with Cyber News. We did a full hour on their research, so I'm going to talk about it for 5 minutes. If it interests you, again, scan at your own risk. There's a QR code if you want to live dangerously on their YouTube channel of that webinar that we did together. But I'm just going to briefly talk about some of the findings that they did. So the main statistics, how many applications contained hard-coded credentials of some kind? About 55%, so more than half. Now, before everyone gets too shocked by this, not all secrets are the same. Not everything's going to give me access to your Amazon S3 bucket. There are some secrets that we discover that I would still definitely consider secrets that I wouldn't want an attacker to have, but won't necessarily give you access to the kingdom. But it would certainly be used as part of a bigger attack to be able to understand and get more information. But still, I would consider that the correct way would be to have 0. So the fact that we have nearly 56% is definitely very alarming. So what was the main secrets that were found? So this study actually only looked at the strings.xml file. It didn't scan the whole source code because that would have taken too long for the research project size. But we're going deeper into that now. The number one was Google storage buckets. So this is really closely in line with the example that we just saw. Data being sent from the app. So the reason why, or I'm just taking guesses of these things, but the reason why I think that is because, you're sending data directly from the application to the bucket. It feels unnecessary to go through the back end or something like that. It feels more efficient, but it's a terrible idea if you're going to hard code those credentials. Other ones, Firebase URLs. We found lots of these. These aren't necessarily exploitable by default. However, it requires that you've configured your Firebase really well. And often what we find is that things like this with like Firebase, the default is insecure. The default is poorly configured. Why? Because companies want you to be able to get up and running quickly. Because if you have to sign your app and get lots of security working to send your first message on Firebase, then maybe you'll use a different service because it's too complicated to get started. But then we don't go back and actually correct and make it more secure. So lots of things like this, Facebook app IDs, lots of different types of secrets that we've found that were on here. The top app categories that Cybernews found, health and fitness was up there, but honestly, no category was immune. You know, we talked about the example of the financial sector, so this shows that really everyone is suffering from these programs almost equally. So there's no kind of avenue of that someone that's doing really well on health and fitness sucks. So, and just to talk about it, a little bit after we did this research, I decided to have a look. It was at the time where there was endless amounts of ChatGPT, I said it right, ChatGPT apps popping up where they're basically mirroring it so that you got ChatGPT on your mobile application. I scanned about 10 of these, and I found 9 of them had their Open API keys hard-coded directly into them. So there's lots of different areas that you can find. That one I found particularly shocking. All right. So how do you securely store your secrets on your mobile apps? How do we hide these effectively so that the attacker can't actually use them? So the correct answer is that you don't. You don't put your secrets on your mobile application. You put them on the server side. And then people will often say, well, if it's on the server side, I have to connect to that server. Yeah, you do. And we just do that like any other application, right? You probably have some kind of login area. You log into your mobile application that authenticates the user with the back end, and then you can do the heavy lifting on the back end. That is the only way. There's no way to be able to hide your API keys effectively if they're on the mobile applications. The only caveat to that is if the mobile application themselves is creating the keys. So what I mean by that is in the example of the bank where they didn't encrypt the images, the app could create an encryption key, store this securely on the device and the hardware that's designed for that, and use it to encrypt it. But we can't use API keys to connect to anything outside of that app. And the other one is if you have a public application with no login, well then you have a public app and you should be receiving public information. Nothing sensitive should be coming from that. So we don't need to worry about it. And please don't hard code API keys in there. All right, so here's some arguments that people always get to me. What about encrypting keys in base 64? And if you want to throw something at me for that statement, don't worry, I'm coming back to it. What about splitting keys? So this means, what about putting keys in 2 different areas and then joining them together? Non-sensitive keys, application keys, this is what I was talking about with encryption, and what about if I obfuscate my code so no one can understand? So the first one, base 64, is not encryption, it's encoding, and it's completely useless for security. The tool that I use, GG Shield, automatically unencodes base 64. So this is absolutely no level of security, and please don't call it encryption. Splitting keys. I'll give you that splitting keys makes it slightly harder for the attacker in the sense that I can't just use something like GG Shield to scan it, because if the keys are split, it won't know that they're partial keys. But if you're relying on slightly harder as your level of security, then you've probably got a big problem, and I just suggest doing it anyway. Non-sensitive keys, I agree that there are some keys that don't give me complete access. However, they tell a story. They let you know information. As an attacker, I'm always wanting more and more information to try and put it together so I can coordinate it in an attack that I can effectively use. So having any kind of keys in there, and it also means that it gives me opportunity that if you've done something wrong, if you've misconfigured something on your end, then that's opening the door for me in lots of ways. Application keys, this is acceptable as long as you store them in the key store or somewhere similar. And code obfuscation, it's useless to maybe slightly harder, but it doesn't really matter. So this is what like code obfuscation looks like. There's some options, you know, in the Android manifest you can select minify. This kind of makes the code less human readable, but it wouldn't stop me using a scanning tool to be able to find these secrets. it just makes it harder for me as a human to look through and understand what the secrets do. This is the tip of the iceberg. There's lots of examples what you can do to make code obfuscated, but really don't waste your energy on trying to make it harder for someone to understand. Put your energy into making it secure. So some things that you can actually do. So signing your application. So code signing, is basically proving that this application in its current state hasn't been modified, that the author is correct, and you need those signatures to be able to authenticate with services. This isn't in replace of storing them securely on your back end, but this is another level of security that you should absolutely have. It means that if you make a mistake and I, the attacker, find your API keys, I can't simply use my machine to manipulate them and extract information. Limit your IP addresses to known machines. So if you have a service that's only meant to connect to this other service, make sure it can only connect to that other service. Limit your API keys to minimal scope. So the amount of times that I will find read-write access or admin keys for a job where someone's just trying to ingest information. So you're just trying to pull information, read information from an Amazon S3 bucket, and you've given me admin keys to do that. Some people will argue that this is more secure because you have less keys to manage, but that's totally bullshit excuse. You're just lazy. So please make sure if you need to create more keys to limit their IP. And then set up access rules. So what I mean by access rules is in things like Firebase. You can set up security rules to be able to understand exactly what people can do and restrict the limits that you can. So we should be doing all of these. None of this is to replace storing the key securely. That's kind of number one. But what happened here is none of these companies, none of these apps that I've scanned think that they have secrets in their mobile applications. No one's doing it really on purpose. It happens because people don't understand the technology and how it's all compiled. So we need to add additional levels of security to catch it when the mistakes happen. When, not if, when the mistakes happen, because they absolutely, definitely will happen. And there's a couple more things that we can do to prevent our secrets from leaking. So the number one here is a change in mindset. And that is kind of assume that you're going to be breached. Assume that your source code is public. If you adopt the attitude that an attacker is going to get into your application, get into your source code, then you're going to change your mindset about how you handle things in that. For me, this is really one of the number one rules that we should absolutely be dealing with, is kind of changing this mindset so that we're assuming that we're going to be breached. We know our source code is going to be looked at from malicious things. And if we put that hat on, then it becomes a lot easier to be able to secure it, and we know a lot more about how to do that. Use automated secrets detection. So mistakes happen, secrets end up out there in the wild. What you can do is use tools like GG Shield to scan your applications after they've been compiled, to scan your code repositories and make sure no secrets are in there. As an attacker, I'm always going to be using automated secrets detection. There's heaps of bug bounty tools out there, like GitLeaks, like Trufflehog, that we can use as attackers to find secrets. So we, as blue teamers, need to adopt the same approaches when it comes to identifying them and preventing them from leaking out in the first place. Restrict access. We've talked about this. Whitelist services, short-lived credentials. One of my biggest gripes is people not rotating credentials. If you're using secrets, make sure you have rotation policies in place. This does two things. One, it means if a key gets leaked, then it shouldn't have a long lifespan, so it's not valid for long. And two, if you're regularly rotating keys, it means you know how to do it. So if a key gets leaked, you know what that key is for and you know how to rotate it. The amount of times that someone will find a key and no one has any idea what that gives access to. And you don't know if revoking that key is going to shut down and destroy production, so you kind of just ignore it and hope the problem goes away. But if we have a rotation policy in place, then we can regularly rotate these keys so that they're not a problem. Use honey tokens is one of my favorite things at the moment, is just using fake credentials to identify when you're being attacked. And give the attackers something to chew on. Honeypots are fantastic lines of defense. Ensure your secrets are always server-side. Don't put any secrets in your mobile applications, even if you think that they don't do anything. And the other one is we find a lot of these because there's misconfigurations. Misconfigurations in your Firebase, misconfigurations in your S3 buckets. We absolutely want to try and reduce that. Use infrastructure as code because it means it's replicatable, and then use infrastructure as code scanning to try and identify these misconfigurations. I know some of these are a little bit outside of the talk today, but this is just kind of my opinion of kind of things that we absolutely should do. So I'm a little bit early, but thanks. If you found this talk interesting, I actually have another talk tomorrow at 5 to 5:45, where we're going to be looking at how we can explore lots of things, like how we can do basically the same thing. There'll be lots of demos of how we can abuse Docker images and package managers, find misconfigurations, and find secrets. So if you're interested in this topic, I'll be speaking again tomorrow in this room at 5 to 5:45. And with that, I'd like to thank everyone for paying attention and being here with me today. It's been really, really cool for me to be able to speak at BSides Las Vegas. One of the goals I had. So thanks everyone for being here and making it possible. And if anyone has any questions, preferably easy ones, then please let me know. Yeah?
Just a second, please.
Oh, sorry. Sorry, that was my fault.
I'm actually kind of like behind on like the Mac OS operating system. Can you just download iOS apps to Macs these days?
No, you can't. You have to use an intermediary. So if you're like, if I go back, I used a tool here called IPA tool. So that's how you do it. But it can be tricky to kind of like use these things. If you just want to do some experiments, there are Play Store and App Store mirrors that do allow you to download it. Just be careful because about 80% of them are super dodgy, delivering malware to you. But there are some legitimate ones too. Yeah. Yes.
Your proposed solution is effectively backend for front end.
Is it, sorry.
It's effectively backend for front end.
Yeah.
Yeah. And so it puts a lot of onus on the user to make sure they're using the correct application, right? So you could have a forged app that tricks the user into presenting their credentials to the back end, and then the back end gives the forged app the credentials, right?
Yeah, but I think that's an issue. Like a forged application is an issue for regardless of whether you're doing this, because I mean, if you've got to download a mobile application, you need to authenticate somewhere. So you're going to be asking your user for credentials to log in. So that does put the onus on the user to make sure that they're using the legitimate application. But this is absolutely an issue that we're facing regardless. I don't think that forcing it to go back end changes that, because if you don't need to log in to an application, then what your back end can do is send your data. So you've got a public app, you just open it up and you can do stuff. You can still fetch public data. So like it might even just be an RSS that your backend is producing so that you can download it if you don't need to log in. But by putting the credentials in the front of that, you're asking for trouble of people being able to manipulate that. Yeah. Yeah, over there. I think it's more for the videos. Yeah.
So would you suggest that there's any value at all at putting either certificates in like an MTLS type situation or cert pinning situation or an API key in an APK or app at all? Or is because of the ability to pull them out so easily, there's really no value there?
I would say there's absolutely no value. It's the same as if, I think you just assume that the source code, like, can you put your source code in a public GitHub repository? If the answer is no, then that's not at a hygiene level that you should be creating an APK from that. Now, there's lots of people that will say things like, what about weather, like maps, Google Maps API keys, or weather API keys, or something that like really offers no value for what I can do? And the answer to that is like, these things still charge. Now, I'm not going to be able to get into your infrastructure because of a weather API key or a Google Maps API key. These are ones that we find everywhere. But you have given me a button that if I press this button, I'm going to charge you 1 cent, or 0.01 cent. right? Now, if I really dislike you, I'm going to push that button a lot. And I'm going to automate that pushing of the button so that you get a big build. So it's still not like, okay, I'm not going to be able to shut down your application. But there's still lots of things that you can do to be able to do just to be able to, for your competitors to run up bills for you, make you unsustainable. I mean, even $1,000 Maps API bill is going to be very suspicious and kind of painful to pay. So I think there's no value. People always argue with me about like certain types of keys and whether or not you've configured it so that nothing but your app can use it. And I agree that all of that's good, but you're relying on the fact that everything has to be perfect all the time. Your infrastructure has to be perfect 100% of the time. I don't like the saying that attackers only need to be right once, because truthfully they need to be right lots of times to get there. But you know, it is kind of true in this sense that you're one mistake away from that key being useful to me. And as an attacker, you know, especially if I'm malicious, I can do stuff with it. So I'd say absolutely no value. You can argue what you want, but I don't think my position will change. Yeah. Just wait 1 second for the mic. Yeah.
How about storing the MTLS client keys in the app, in the vault, like you mentioned, secrets manager?
Yeah.
So is that the standard practice?
It should be. Like, you know, like putting secrets. See, there's different levels. The talk after me is going to discuss secrets maturity model, like some different levels of what to do, and there's different levels to it. Now, I differ from the general security opinion of this. So if we look at the very highest level, we use HashiCorp Vault. We're using dynamic secrets, so secrets are being generated and destroyed after one-time use. All our secrets are centralized there. That's the best practice. But is that reasonable for a small company to be able to manage a heavy tool like HashiCorp Vault and that? So then you go down a level, and I say like no, because the chances are you're not going to use it properly, and you're not there yet in your maturity, so you shouldn't try and force this crazy tool on them. If you go down and you have secrets managers, if you're using AWS or GCP, they have secrets managers. They're less secure with less features, but they do the job, you know. And so I'm an advocate for be reasonable with what you want. Okay, aim for the vault, have a path to get there. But if that is what you need, because the argument that I have is because people always argue with this. I'm all about finding secrets in weird and wacky and wonderful places. So you're arguing, should I use Vault? I'm saying just don't put them in your damn APK. Like, you know, like let's start there. Don't put them in your source code. We can talk Vault all you want, but we're not at the stage where we can, you know, so just use whatever you're going to use. Vault is the best, or there's other services out there, like 1Password has some good ones, or they've got some new developer tools, Doppler, A-Keyless, lots of tools out there that do great things in managing secrets. But just pick the right tool and actually use it, and just make sure you're not hard-coding secrets. They start there, and then we'll worry about the rest. Yeah, hopefully that answers your question. Oh, Matt. This one's going to be hard. I can feel it.
No, I'm really kind of curious. What areas do you see for improvement for that secret scanning aspect of it? Because a lot of things look like passwords. How do you see areas that need additional research to make your job easier to find these secrets?
Yeah, so I mean, secret scanners are actually getting better and better all the time. I think a few years ago, secret scanners were kind of creating lots and lots of false positives. I mean, at GitGuarding, we've put lots of work into reducing that. How we do it for, it's easy for secrets that you know, like an AWS key or Twilio key, because I can check with the service. Hey, is this real? Yes or no? Yes? Okay, good. So that means I can cast a wide net. It gets tricky when you're talking about generic secrets, secrets that are for systems that you've built that I have no idea exist. And so how we've managed to do that is we've created flags in post-validation. So we find a high entry string, looks like a secret. What else clues in this, do we know? Can we understand what this code is doing to flag it? And we've been doing that. But in all honesty, I think that secrets detection and high-quality secrets detection over the next 4 years is going to become an absolute given. Like you won't get away with having crappy secrets detection. AI is helping in this to be able to digest that. So we have a record of everything that's happened on GitHub for the last 7 years publicly. So now with some machine learning and AI, we can really start training it. I think that the detection is going to get as good as it possibly can quickly. But I think where the problem comes in, and particularly as large enterprises, is not so much the detection of it, it's more like, how do you actually effectively remediate this issue? You've got 1,000 secrets, you've got 2 AppSec engineers, what are they going to do all year? All they're doing is rotating secrets and investigating them. So to me, it's all about streamlining that remediation process and improving that area so that we actually know what to do. And then not just putting secrets detection in like your source code or code repositories, put it everywhere along the way. Do Git hooks to prevent them getting in the code repositories. Do scans after your application has been compiled. All of that kind of area. So, I mean, there's lots that can be improved. I think detection itself is getting better and better across the board, not just with us, but everyone. Even the open source tools are getting really good. So I feel like that's going to be a given, which hopefully will help. But where it's going to get complicated is what you do after you found them. How do you actually deal with that? Any other questions?
Everybody, let's give it up for Mackenzie.
Thanks, everyone. Thanks, Jessica.
to whip up my appetite. Don't leave me here high and dry. Oh, well, I don't wanna jinx it, baby, and twist myself at the spine.
Good afternoon. Welcome back. Welcome to PasswordsCon Room. Let's get excited for our next speaker, Dwayne McDaniel, who's going to be talking about, do you know where your secrets are? Exploring the problem of secret sprawl and secret management maturity. Let's go. Sponsors, we want to thank you, especially our diamond sponsor, Adobe. Shout out to our gold sponsor, Blue Cat, Plex Track, and Toyota. It's their support, our other donors, and you all which make this possible. Please turn off your cell phones. Nobody wants to hear your Bone Thugs and Harmony ringtone, okay? If you have any questions, save it to the end. With that, further ado, Dwayne, what's up?
Hey, thanks very much for that intro. If you don't want to turn off your cell phones, just turn off the ringtone. But yeah, please take pictures if you want and post them on the internet, please. Thanks for all coming this afternoon. Hope everybody having a good B-side so far? Awesome. It's so apparently. So before I give my intro, I have a prize hat up here. I'm asking specific questions. Who saw the last session in here? All right, you guys are going to get a chance to win some prizes from me based on what you heard before, because I work with Mac. So I live in Chicago. I've been a developer advocate since 2016. Thereabouts, depending on how you count developer advocacy in the early days. But mostly come from the DevOps space, the platform play space. Security, this is my first BSides Las Vegas, so thank you all for having me. I'm very nervous to be here. It's the biggest imposter syndrome I've had this year. This is like my fourth BSides, so you guys are all special. If you want to hit me up on X or Twitter, or whatever they're calling it these days, it's MC Dwayne, and it will be until they take the service down. I'm also on Insta and all the other places, MC Dwayne, including GitHub. I should probably put that on here because that's a more reliable platform than all of them, and hopefully it's more reliable. And hit me up about anything if I'm talking about it today, or if you want to talk about karaoke, who's going to karaoke tonight? Okay, it'll be me singing by myself. But if you want to come hear me sing by myself, or you want to talk about rock and roll, you want to see a rock and roll show, please hit me up. I'm always happy to talk about rock and roll. Very quickly, I work for GitGuardian. They're going to come up a lot in this talk because a lot of the research was done by them. In fact, all of the research, because that's where I work. That's just how it works. So we have a booth over there, and we can talk to you about hard-coded secrets and checking how they leak and all that. But let's leave that for the hallway over there. So, in summary, just don't leak your credentials, and you're good. And you can go home and sleep well at night. You've done it, success. Unfortunately, I have to keep giving this talk and other talks like it. So 2/3 of this talk is just going to be a bunch of facts and figures that might be terrifying, especially if you weren't aware of them before. And some people will just nod along and say, hey, I've heard this before. I've heard things like this before, specifically the guy that talked right before me, Mackenzie, my colleague, who's also a developer advocate at GitGuardian. We didn't plan that. That's how the schedule worked out. But if you do feel panicked or fear like you're talking about my company, just recite the litany against fear and everything will be okay. After all, we're talking about the internet. Nobody really dies on the internet, do they? That's maybe not a great joke. But Uber, they're still out there. They still exist. But this happened to them. Anybody remember this from 2002 or 22? So super admin gets phished. And they're doing it right. They got 2MFA on, or two-factor authentication on. And the theory is he got flooded with so many requests that his thumb slipped. We'll never know. Maybe he just got mad at Uber and said, okay, I'm just going to let this one through. Anyway, the request went through. The spammer, or the attacker, who was from the Lapsus group, which is a UK-based hacking group, got in, was able to take that superadmin's credentials, go through the VPN. Long story short, found PowerShell scripts chock full of hard-coded credentials for everything. And he got into everything, including their HackerOne account, and told HackerOne, hey, I hacked into Uber, I'm cool. And they're like, yeah, that's probably not true. So he floods their Slack with memes and takes over all the channels. And they're like, yeah, this is some prankster. And the next person you talk to is the New York Times, and that's why we know about the story. What did he actually steal? We'll never know. Did we see a wall of new security job postings from Uber the next day after that? Sir? Yes, we did. Circle CI, who got affected by this? Who had stuff in production for this? Is anybody here a developer? Does anybody use Circle CI? Wow, that's a first. That is literally a first for me giving this talk bringing this up that nobody got a hit. Basically, the kerning messed up, and I'm really mad about that because that was fine 10 minutes ago. Anyhow, long story short, attacker hits a remote developer. Remote developer's environment gets compromised. Attacker gets into the Circle CI internal frameworks and internal platforms, plants malware that starts stealing credentials. That then takes those credentials and gets into customer accounts. The same day that they come out and say, hey, we had to rotate all of the access keys. Sorry if it took down your production instance, but we had to rotate them. Same day, a independent researcher said, hey, something's going on with Circle CI because all my honey tokens went off. And now we know why. Someone actually got a hold of their credentials and was attempting to exploit them. I don't have fancy graphics for everything else. This is one of my favorite stories. Not in a good way, but just I think it's interesting. Anybody drive a Toyota? Do you have the T-Connect app? Yeah, that's the right answer. Toyota back in 2017 subcontracted someone to do maintenance on it. Good idea in general. For some reason, that subcontractor pushed a portion of the T-Connect code onto a public GitHub repo. Why, we'll never know. It takes a security researcher until 2022 to figure out that that contains an actual data key that affected 296,000 customers. Nothing super sensitive, so email accounts and some identifying information, but no like credit cards. So Toyota Japan puts out a really nice blog post and statement saying, hey, you're probably going to get phished. Be on the lookout. It might not be us. Just be aware. But for 5 years, it took them 5 years to figure that out. AstraZeneca. All we know are the very scant details that got released, but it was the perfect storm, tempest in a teacup kind of situation where a developer pushes the test environment credentials into GitHub public. No big deal, it's a test credential. Like what on earth can happen in a test environment? Well, somebody else inside AstraZeneca pushed actual customer data into the test environment. We don't know how big this was. We just know what happened. Because it's HIPAA, they can't just come out and say, this many customers, and they didn't. Unlike airline crashes that come out immediately and say, hey, we had a crash, we are gonna fix it, and here's exactly what went wrong, and here's exactly the steps. In security, we all just kind of get, we'll make best effort, sorry, and move on. This one's kind of scary to me, because I am an AstraZeneca customer. We live in this world of constant cat and mouse. Literally, people trying to get in and get our data and our hardware resources, our machine resources. Alfred, the creator of CyberCop, the first commercial honeypot that ever got released, said this, and I think it's a great, very nice summary of why we should take this stuff seriously. I think it can be reduced to this. Attackers, and this is supported by like Verizon DBIR report. If you haven't read the DBIR this year, go read it. It's a great chock full of things. Ransomware is kind of ebbing and flowing, and it turns out that Log4j, we got mitigated, and it's kind of not, it's still a problem, but anyway, DBIR is full of good info. But 80+% of all attacks are organized crime at this point, of malware attacks. Yeah, there are nation-state actors. Like we all know about Microsoft and their forged key that happened last month. So that was the China-backed hacking group attacked them, and guy was trying to get into the State Department and Commerce Department. That stuff happens. There are hacktivists that just want to make companies look bad, like the kid from Lapsus. He was 19, so I say kid, young man from Lapsus, who did it for the lulz, apparently, and just to make Uber look bad publicly. But most people are after the top two. Anybody want to guess? This isn't for the prize hat, by the way. But anybody want to guess what, number one, why they want your machine resources? Why do they want your data? Money, and how do they get your money? Ransomware. My favorite joke I heard all of last year was, how did the hacker evade the FBI? They ransomware. Yeah. Thank you. Thank you. That's the exact right response. Thank you all. The one thing all of those attacks have in common that I went through, and again, I'm not trying to scare y'all, but this is reality, is that there was a credential somewhere along the path that gave the attacker access to other things, or a credential that was misplaced because it was hard-coded when it shouldn't have been hard-coded. Attackers, going back, if you're here for a second, what we see them commonly do to get these things is lateral slides, lateral movement through the environment, trying any door they can get their hands on, and then escalate privileges up. Let's take over the machines, escalate the privileges as high as we can, and then go see what else we can get into and escalate those privileges. Lateral slide, escalate up. Time and time and time and time again. But because of that, we kind of know how to defend for that, or we should, and that's what we get to in the later part of this. But when it's just a quick definition, I use the word secret and credential interchangeably because they mean the same thing to me in my head, but this is what I mean by it. It is an API key, a username, anything that gives you access to another system or decrypts data. That's it. Like if it's an ENV file, a CRT, or what have you, an actual SSH key, something that should be secret. You should not be sharing that out in the world. This is how it commonly ends out in the world. And I do this all the time. Anybody want to guess why we do this? It's easy. And when do you need to do something easy because you're in the middle of a rush? Testing and debugging. Like, I just need to make sure this credential works. Is this the right password? And if you do it locally and you take it right back out of your local file, who cares? That's how we debug things. That's what we do in life. The problem is then we add, commit, and push. And that's where the problem really escalates. To the point of, we put out this report every year. Feel free to download it if you want. That's the first big third of this talk, is just going through these. So we, as a platform, since 2017, have looked at every single public Git commit. You can as well if you want. api.github.com/timeline, or maybe events. I always get the two confused. But there's a public API you can just go subscribe to. It's in JSON. It's over 6 billion, 60 billion commits deep. It's insane. Last year alone, there were over 1 billion commits that we scanned. Again, just public GitHub. So not public Replit or GitLab public or anything like that. And we're seeing a giant growth in GitHub year over year. 27% increase in developers just in 2022. At the time, the fastest growing language we were seeing was HCL. Anybody know what that goes to? Terraform, yeah, that's great. You guys are awake. I'm loving that this is just far enough after lunch that you're still awake and the coffee's kicked in from the 3 o'clock coffee rush. All right, first question from the prize hat. And probably heard this stat if you were in the last talk. Who knows how many secrets were discovered last year in public GitHub by GitGuardian? 10 million. Who said that? You get a piece of candy. There you go. All right. Yeah, 10 million. That's a terrifying number, and that's a fun way to deliver it. Yeah, we found 10 million hard-coded credentials. This was a 67% increase over the previous year, and I have a slide that lays that out. But this isn't cumulative. This isn't over all of time. This is just new ones out of that, how many billion? 1.27 billion commits. How we did it? That's public as well. We built our own detector engines, but we documented it all out there, and that's where you can go look at the actual how we did it. So they're just saying it's all supported out there. All right. Second question. On average, how many commits per 1,000 commits contain a secret? So I need hands now because I can't just hear. All the way in the back. What? 100? A little high. Anybody else? 10? A little bit high still. Anybody else? 56.9. That's a great specific, but no. Anybody? Anybody else? I will give it Price is Right rules. Over there. I'm not going to throw it, but 5.5. You get an apple. You can come up and get it later, or if you want to pass this back here. Here, I'll throw it to you, and you can pass that back to him. You get an apple. 5.5 out of every 1,000 commits on GitHub Public last year contained a credential, a hard-coded credential. That means 1 out of every 10 authors pushed one. You can see the previous years, like there was a little over 6 million we discovered in 2021, over almost 3 million we discovered in 2020. And again, this isn't a cumulative number. This is brand new ads. And when we stop and think about like the fact that GitHub itself only grew 27%, this is startling. So who's doing this stuff? It turns out it's everybody. Can't just be new people. Yep, that's the answer. So this is where they're coming from, and I don't want to point fingers, but it kind of makes sense when you think about general populations. But does anyone see a weird missing nation off of this list? Any security researchers in here that investigate where origins of attacks come from? Yeah, Russia's all the way at the bottom. It's on the list, but there's one missing. Oh, yeah, they should definitely be on there as well. But I think that's tied to the other answer. So North Korea isn't doing public GitHub. That's the other reason they're not on here. Indonesia. So go look at where attacks are coming from, and you're going to, surprised by your logs, you start tracing IP addresses. At least in my research, I found like a shocking number of like Indonesia, and like, why are they coming from Indonesia? And I've talked to other people about this, and there's no clear answer. Maybe they're trampolining. Maybe North Korea is using Indonesia as an attack vector. All we know is that Indonesia isn't leaking their secrets onto public GitHub. That's what this data tells us. Anyway, moving on. So if we look at specific categories of, oh wait, that was supposed to be one of my question slides, wasn't it? Oh no. Oh, I moved it around. Sorry, that was supposed to be a question slide. So if we look at which specific secrets got shared out there, what types, other is the biggest category because other is literally the bucket for all of the other like 2%, 5%, 7% that weren't big enough to show up at the 3.8. So let's ignore the other for a second, and I should have just taken that out. But data storage is number 1, cloud providers number 2. Which totally tracks to what we originally talked about. Attackers are only after 2 things, and they're disgusting because they want your money. Messaging systems. Why do you think messaging systems are important? What? Auth? Others? Yeah. I think what I heard between those and the answer I'm looking for was plotted out, is there's a lot of companies that think, okay, I'm just going to pass this key between developers through the system. It's better than email, right? Slack, yeah, it's slightly better than email. Anyway, we still look at generic detectors as well. So we have specific detectors that look at like specific providers, and then general generic detectors that look for things that look like high-entropy passwords, things that are base64 encoded, bearer tokens, things like that. Generic passwords is the vast majority of that. Now I'm just getting into stats and figures on it. But all right, we'll go back to the specifics. Who thinks they know the most commonly leaked specific secret in 2022? AWS. I would have thought so too, but it wasn't. Anybody else? What? Oh, sorry, he said AWS. Any other guesses? Nope, no other. Any other big providers out there? Anybody want to guess? Google. Who said Google? You get a marker that if you spill something on yourself, it'll white it out on a Tide pen. Yeah, Google API keys. 9.7% of all the 10 billion or 10 million we detected were Google API keys. You can see the rest of it splits out. Again, other skews everything, and it's weird, and the colors choices were not mine when we built this. But you can see, like, that's how it spreads out. All right, I can talk about stats and figures all day, but what I want to get to is later here. What's the fastest growing leak secret we've seen in 2023? Technically open API, but I'll give it to you. You get Progress Software Kleenexes. I didn't just clean out my bag to do this. I swear, I had candy in it and didn't eat all the candy. But yeah, so far this year we found over 50,000 incidents with OpenAI keys. It's not the largest number, but it's the fastest growing, considering last year there were basically none. It was not even detectable last year. I went and dug in the stats and I forget it, but it's a very small number that's in the other category. All right, but what does this mean for your enterprise? These are all interesting stats, sure, and for you as developers to think about, but what does this mean for the companies you work for? Well, we went out and asked. We asked 507 people that said they're decision makers in IT, and we put together a report, what they said, in the voice of the practitioners, state, secret, and AppSec. It's a really long title. All right, only got 2 more of these, I promise. What percentage of IT leaders said they experienced a secret leak in the last 18 months? A little bit lower. It's Price or Right rules, by the way. 100? I think that's more accurate. No, what did you... any other guesses? 26? Higher. 36. That's a good guess, too. 75. 75 on the nose. You get some notepads that say Adobe on them. 75% of respondents said in the last 18 months they had experienced a secret leak. 60% of those, or 60% of all people said it somehow impacted their company and employees. That's the reality, and that's why we need to get on top of this and solve it, because we're starting to really impact the bottom line for our companies. 94% said they're planning to improve their secret practices in the next 12 to 18 months. This is my ultimate problem with survey-based research, is people can say a lot of interesting things. And this is proof. This is select all that apply. Anybody see a problem with the math on this, like immediately? Yeah, because all these IT leaders are like, yeah, I'm probably going to fix it. Yeah, we're probably dealing with this. Yeah, but we're all dealing with budgets. There's only so much time in the day. But everybody's got this plan that one day we're going to fix it. One day we're going to do something about it. We know it's a problem, and that's what I keep harping on. For the people that did experience, and I know I went through that real fast. I'll leave this up here for a second longer. For the people that did experience that, 27% admitted that they were relying only on manual code reviews. Who thinks that's a good idea? Yeah, I've never had anyone raise their hand on that. I love manual code reviews. I think there's a serious value to the manual code review. How else do you teach junior devs anti-patterns? How else do you teach them this is not lining up with the business value of our company? That's what code reviews are great at. The human-to-human connection, pair programming, let's get overall better together. Finding an individual string that's wrong, man, humans are terrible at that. That's what machines are great at. So for people that did report they had a leak, this is their self-reported number, average number of occurrences, and by occurrence, I mean, if the secret is shared within a repo, how many places in the repo did it appear? Any other guesses? Price is Right rules. It is 3.95. Last piece of candy, right? I thought I said 8. You said 3. All right, that's last piece of candy, and that is the end of the prize hat for now. I got one more thing, but I don't have any more questions. All right, done with the prize hat. Now we're done with the silly part. I did that to kind of, because this is all terrifying news, right? Like, none of this should make us sleep well at night. So what do we do about it? And that's where I want to end with the last 10, 15 minutes. Who here is familiar with Dora metrics? Dora metrics, the Accelerate. Anybody here read Accelerate? Okay, there's a book called Accelerate, and the research they did in there formed the DevOps research. I don't remember what the A stands for. Not association, but basically, this is how you measure the success of a DevOps organization. Actually, let's just real quick. Dora metrics. Metrics. Yeah, how to measure software delivery. So you can go to, well, this is not the one I was looking for because the Google has the official one. There we go, Google Cloud. But we can take how all DevOps organizations perform and break it down into these 4 leading metrics. Deployment frequency, assessment, that's what it is. Research, DevOps research and assessment. I never remember what the A is for. Deployment frequency, how often an organization successfully releases to production. Lead time for changes, how fast they get a change out the door. Change failure rate, the percentage of deployments that cause a failure, and the time to restore a service. If something breaks, how long does it take to fix it? You can take just these 4 metrics and judge the overall health of a DevOps organization. So says their research, which is also survey-based, but half the book of Accelerate explains why that works. Nicole Ferguson and other people wrote this. Gene, Kim, a lot of really smart people. So go read Accelerate. So we took that idea of like, well, how do we map out what a successful organization looks like? And we said, this is wrong. This isn't good enough. This is what Google's entire developer documentation says if you leak a secret. Simply just go re-architect your app. Good luck. They didn't even say good luck. I don't recall saying good luck. This isn't good. This doesn't tell you what you need to know. So we think that it starts with, hey, use a vault. Cool. Either like something off the shelf like HashiCorp Vault, or if you're using Azure, Azure Key Vault, or AWS Secrets Manager, or what have you. That's a good start. But that's a start. So how do we map out how we get to success? And I think it comes down to really 3 pillars. You got to have people invested in the process, that trained and they know that, hey, this is a problem we need to fix. We got to stay on top of this. You got to have clear processes that are documented that show this is what we should be doing, and here's exactly how we do it. And then you rely on the tools. Because if you just throw developers Key Vault, you're not going to have success. Key Vault is good, but it's not something you do on an individual basis if you're working in a team. It's a team effort. Same thing with HashiCorp Vault. Yeah, you can use HashiCorp Vault completely on your own by yourself as a developer, but if you don't implement it as a team, you're not going to find the results you want. And if you try to automate things completely on your own without having the processes in place, everything's going to fall apart. It's the 3-leg problem. Remove one of the pillars, everything falls apart. But anyway, we think it boils down to 5 levels. And of course, computer science, we're off by 1, so we start with 0. And this isn't never meant to be an accusation. So never feel like, hey, you have to be better. This is our general guide of like, here's how we think teams can improve over time, and a general roadmap for you. So just a place to gauge where you are as an org. And then how do you have that conversation with your DevOps leads and your operations team and your CISOs and your CTO? Say, here's where we think we need to get to based on where we're at the moment. So level 0 is a lot of organizations. That's why we put it at the base of the pyramid. On the secret management side, they're hard-coding credentials, and we already went through all the rigmarole in the first part of this talk of why that's bad. It's just everything's unencrypted. You're throwing things just willy-nilly into your code base, throwing it through your CI environments, and there's a password in place somewhere that's hope for the best, or the best answer you can have of what are you doing for security? Oh, we have a firewall. That's not good enough. And then the secret detection side, how do you know if people are leaking credentials here and there? You don't. You just don't. You're taking their word for it. You're not even doing manual code reviews at this point. Again, not an accusation, just this is where we see like the very bottom level. If you're starting a project and you've never thought about this stuff, it's probably where you're at. And then you get people that are starting to think, hey, maybe I need to use an env file. Because if I store my env file outside of the repo, that's what AWS tells me to do with the .aws/credentials file. That totally works, and it does. Problem is, sometimes people move that into the repo, and then they forget to set git ignore, or they modify git ignore that it allows it to be shared, or they copy paste the entire repo or the entire folder and the env folder into a bucket. Last year there was a firm that found 1.5 million Git repos that contain secrets in public S3 buckets. People just threw them there because they could store them out there for cheap. Git ignore does not work outside of Git servers. But we're moving in the right direction. Let's take our config files and let's group them together. Let's make sure we're storing things externally from our repos. And you're starting to think like, okay, maybe we shouldn't hard code. That's a good first step. Oh yeah, and log data. We finally realized that our plain text credentials are in our log data. Maybe we shouldn't do that. Maybe we should build sanitizers in there. Please. But secrets aren't really scoped. Like everything is just fully allowed to do everything because that's fast and easy. And now you're starting to periodically look through and say like, okay, manually, did we check for this? And secrets are in fact rotated manually sometimes when you remember it, when you think it's a good idea. The alarm goes off. Hey, time to rotate that AWS key from last year. Again, better than where you were before. You're on the right path. That's the conversations you should be having. It's like, how can we do this better? If you include one of these 1% every day, you're going to get to the next level pretty quick. So intermediate people. Now we start using vaults. Now we start using secret managers. Now we're starting to scope things correctly. So if someone does get a hold of it, the only thing it can do is a very specific limited thing that you cannot escalate. It doesn't allow escalation. Storing things dynamically, you're loading the secrets in dynamically from the vaults correctly everywhere. So if someone does get to your code, they see vault.projectname.secretname.secret. That's programmatically calling it in. That's awesome. Like if I was an attacker, I'd think, oh man, I don't got time for this. Got to figure out some other way in. You're starting to scan things at the developer level automatically, and you're starting to you scan continuously at the PR process, the merge process, the PR, the merge request process. That every time the code's gonna get merged into your main branch, yeah, we're scanning at that point. And starting to look at your build outputs to see if any secrets got jammed into there. So scan your Docker images, your PyPy packages. And that rotation is still manual, but they're rotated, at least periodically. And you kind of see where this is all going, and I'm starting to run out of time, and I do want to leave time for questions. But level 3 is, okay, now we're going to start doing this for real. Everybody is going to use Vault. All right, there is a clearly defined process around how to use it, and rotation is clearly defined, and it's a regular scheduled event, and we know when it's going to happen. Now we start actively monitoring logs because we know that, hey, this stuff's going to get leaked. Let's start actively looking for it on the regular with some tools that let us do that. Datadog, Logs.io, there's not one winner here. There's a bunch of ways to do this. And now developers are starting to use tools to scan before they push. This is where Trufflelog comes in, Git leaks. We have GG Shield. If you're just looking for pure detectors, there's a lot of solutions out there on the open source. AWS Secrets, or AWS Labs Git Secrets is another good one if you're all in on AWS. But you're starting to build that into your Git hooks system. So every time you go to make a commit, automatically check. The remediation process involves the developer. Now you're getting asked, like, why is this here? And you start getting to holding a developer's account for why they're doing that. Maybe it's a test credential. Maybe there's nothing to worry about. Maybe Maybe they did it by accident. Maybe they didn't know. Maybe they weren't trained. Maybe they didn't get the notification. Maybe they didn't read the memo. We can start fixing the people and the processes and the tools all together. All right, and then we get to our expert level. No matter where you are here, this is where we think you can get to because we know companies that are at this level. We work with them day in, day out. There's a central vault storage or hardware managed device storage that has complete clear access logs. You know exactly who's called what secrets when, who changed things, who was in the system at all. It's all clearly logged and actively monitored. Secrets are dynamic, meaning they change constantly. The best passwords are the ones that do not exist, and you've gone to a system that is relying on IAM rules wherever possible. And the only passwords are the ones that are mandatory, but those are very short-lived. So if someone gets a hold of it, they probably already expired, the one they have the hold on. You're checking throughout the entire pipeline at every step. That's what I'm saying. The OpenID Connect, you're starting to replace passwords with tokens, short-lived tokens. Yeah, and you're enforcing things. So that's the process and the people part. Like, hey, you didn't do this right. Thank you. How do we fix that? How do we, as a team, make this better? Now you're scanning every single commit every single time it moves, even before it's made, consistently across the board. Everybody does it. If not, and it still shows up, there are consequences to that. Not to be heavy-handed, but it's, hey, why are you pushing secrets continually? We told you not to do that. Here's all the training. Here's exactly the tools. Now it's a you problem, a specific person problem. And monitoring is ongoing, continual, and secrets automation, or secrets rotation is completely automatic. Has anyone here flipped on AWS automatic rotation? Or I guess AWS users in the room. How many of you use the secret rotation automation? It's there, it's in the documentation, it's one config, right on. Please, be proud. With all the other tools you can do it, there's systematic ways to go about this. So again, you can download this, but this is what we would love for everybody to go have that conversation with their teams. Like, hey, we think we're at a level 1, but we're almost to level 2. Why don't we talk about processes to get to that, to get to here? We want this to be a roadmap of where you can find success, not a judgment, not a, we should feel bad. Nobody should feel bad. It's a journey. Nobody's born knowing this stuff. Not even Linus. So in conclusion, it's a constant cat and mouse game, and the stakes are very real. I was talking to a colleague who said their company leaked an AWS credential. They caught it within 5 minutes. They got a bill for $150,000 because they caught it, they pulled it out of the code, but it still took a while for them to rotate it. That's the stakes we're playing with now. OpenAI, there's a dark reading article, I didn't quote it in here, but actually I did quote it in here, but it's Replit. Replit does not have any automated checking for their code. If you leak OpenAI secret onto GitHub public, there's a deal between GitHub and OpenAI that will invalidate that. They'll send an invalidation request immediately, and you're safe. You leak that same credential on Replit, it will live until someone takes it down, like you, or then send your own invalidation request. Yeah, somebody got a bill for $110,000 because a hacker group found it on Replit and passed it around in Discord. And everybody got a free AI that day. But that's the stakes we're playing against. So again, don't want to make anybody feel bad about this stuff, and I don't really want to scare anyone, but bring it to your attention, have the conversations internally. I'm Dwayne, I live in Chicago, I've been a developer advocate since about 2016. Hit me up on Twitter about anything, and if you want to sing some karaoke or talk about rock and roll, I'll be around. Oop, wrong direction. Thanks. with that, I'll open up any questions. And we do have a mic because we're on the internet. Right there.
Hi, great talk.
Thanks.
You mentioned you scan all of public GitHub and you
Yep.
find these credentials. I imagine the vast majority of people putting secrets into public GitHub are small developers, small companies, people that aren't going to have tremendous amounts of professional experience. You also scan private repos as well. Do the metrics line up? Is there a difference in the ratio of the metrics from professional developers and enterprise versus what you find on public GitHub? Is it comparable or is it?
It's actually really interesting to bring that up because we just are talking about that internally. What I can share publicly, because again, we're dealing with private repos and customers and NDAs and all that. What I can share is we have severity scoring and it's automatic on the system. So if it's valid and it's public, it automatically gets a critical score. We do see a curve. I can't say exactly the numbers, but we do see a curve downward of the more professional the organization, the higher they are on that list. But I think that's the more that curve. So it's less severe, less criticality from those teams. But that's a result of their maturity, in our opinion. That's what we think is actually happening. Is they're consistently using HashiCorp Vault, so they're leaking a lot fewer secrets that hit that criticality curve. So it's a combination of those things. So it's not like one thing I can point to. It's there's just juniors or it's a brand new company. But yeah, can't release those numbers on the individual. But that's a good question. But yeah, we do see people that are checking consistently are higher on the elevation scale, and there's nothing controversial or secret about that. All right. Any other questions? I did have one other prize, and since you asked the first question, it's a cord minder. Sorry, I almost hit you in the head. Didn't mean to do that. There you go. It's cord minder.
So you mentioned about a manual code review and.
Who's it? Oh, right there.
Yep.
Okay.
So you
Sorry.
mentioned about manual code review, and it's kind of okay, but not that good. But any automated tools that can actually scan this and give us some more detailed input on the code?
There's a number of providers out there. Full disclosure, GitGuardian's one of them that looks for hard-coded secrets. Truffle Security is another one I would name off the top of my head. If you are all in on GitHub Advanced Security is pretty darn good for what it is, but it only works on GitHub. Is the ring on there. Thanks very much for coming. But yeah, there are other providers out there. And then there's the whole world of ST, static code analysis, static application code testing, SACT, SAT. I'm getting my acronyms because I'm really at the end of a talk. But yeah, then there's the static code analysis tools out there, and those range all over from Sneak to there's a ton of them out there. Sneak comes to mind first when the ones I always think of when I think automatic code review. But yeah, if it's a combination. If you use I believe if you use testing tools in conjunction with humans, that's the best outcome. Because manual code reviews, again, how do we improve the business logic? How do we teach juniors not to code anti-patterns? Manual code review is best for that. But it's back in my website building days, regression testing. Pixel to pixel, my eyes ain't that good. I can't tell you the difference between two shades of purple. I just can't. Backstop.js could tell me every time, and it was automatic, and it took seconds. And I would use it for that. But for copyright, or for actual copy, I would want the person that has an English degree on the team to actually read over what I wrote, not just trust a machine. Okay.
So an incident I've actually had at my place of work at one point was...
I'm sorry, can you speak up?
An incident I had at my work at one point a while back was we had a contractor come in from a consulting company to help us build up and install a product. And a few years later, one of our guys actually went, hey, do we know about this Git repository? And found that on public GitHub, the guy had uploaded a bunch of infrastructure as code type stuff, including secrets in that. Thankfully, by the time we discovered it, that test environment was gone. None of the passwords were active.
Good.
But theoretically, at a point in time when that was uploaded, there was potentially a test system where there were these passwords there, and like you can have all your, we actually use Vault, and we've got our own Git server, and even if we had scanning on that, what's the sort of approach when you do have what's stopping a junior dev or some external person or whatever just Git push to a public repository? Like how do you find that when it's not really it's not your repository, it's who knows, right? Like it can be anywhere.
If it's pushed privately, you're right. That the greatest thing that Git gives us is the ability that everybody that touches the code has the entire repository. The most terrifying part of Git is that everyone that touches the code has the entire repository. This is the double-edged sword. If you actually type man git into a terminal, it says Git, the stupid content tracker. It's dumb. It has no idea what it's doing. If they do it publicly, there are tools that will look publicly. Again, that's where we started from. That was the first thing that our founders built was, let's look at every commit on GitHub and find out what strings there are. So that's our public monitoring product, is literally look for your strings, look for your vars, look for your secrets, and let you know when they pop up out on GitHub public. We're not the only people that do that, and other solutions that pop to mind, I don't have another solution that pops to mind immediately, but I do. There are other systems. I believe CrowdStrike, but if there's anybody from CrowdStrike in here, let me know if I'm right about that. But there are other tools that also can help you monitor public places. But that's the Toyota problem, is that their subcontractor pushed a repo publicly and didn't tell anybody, and it took a security researcher 5 years to figure it out. There are other systems that are constantly scanning and monitoring, and that's only gotten better. GitHub itself will probably tell you at this point, depending on what secret it is. Their secret detectors are, again, pretty good. And if it's an AWS key, AWS is going to find it immediately. AWS is constantly scanning the entire internet, constantly, because they have to. Any other questions? Because we're right at time. But there's nothing else after this, so I got a couple more minutes. Oh, we got a question. Let me get the mic up here.
I can try to be loud. That's better.
It's for the internet.
Oh, okay.
You can be loud in the room, but the internet can only hear so much.
So usually when we're talking about like credentials, we talk about like MFA or two-factor authentication.
Yeah.
What level do you think that would come to if we were say you're adding a passphrase to your SSH private keys, or maybe there's other protections in place? So even if in the code it is leaked, maybe there's like network controls so that the server can't be reached from a external source.
100%. That's a great point. And that's something I guess I don't talk about enough in any of this stuff because I'm so focused on the credential end of it. But this is one piece in the larger equation. If you talk to us at the booth, the first thing I say is we are a code security platform because that's what we're focused on. Network security, the biggest thing I think people should work on is egress. Like, know exactly where that traffic should be going, and if you don't know where that traffic is going, go fix that right now. Fix that before you fix this. Don't tell my boss I said that. That was on the internet, damn. But go fix things like that. Because, yeah, if the call shouldn't, that's the talk I saw earlier on MFA, issues with MFA. If the call is coming from somewhere weird, don't accept the call. But this is all part of it. So, yeah, overall comprehensive security strategy, yes, you should have your network so locked down that if someone does get it, it doesn't work. But part of that strategy should also be we rotate so fast that they get the code from yesterday, it doesn't matter. That line in Return of the Jedi, their code checked out. It's a little old, but we're about to let them through. Like, that wouldn't even work in ancient Rome. Like, that's a dumb idea. Like, a password should be immediately invalid as soon as it's used, or it just shouldn't exist. But yeah, that's a good point. The more secure your network is, the better security.
Yeah. Or like adding passphrases to SSH keys or something like that.
Yeah, password and SSH keys should be a mandatory practice. I 100% agree with that.
Yeah. Is that like level 2, level 3? Like, I don't know.
Oh, if I was gonna map it,
I don't know. I'm trying to go back to the talk and stuff.
Oh, if I was gonna map it, I would say it's somewhere between 1 and 2.
Yeah.
But definitely 3, you're gonna be using it consistently. Because 3 is where the developers are starting to do things consistently. Level 4 is where it's mandatory across the board. Everybody does it, and it's build into the process. But I think level 1 is where you should start having that conversation of, hey, do we do that? Oh, we do now? Okay, let's go along that path, because there's no real hard boundaries here. It's like overlapping. But I like that.
If I have time to, one further question is, if you're doing all this scanning, how does disclosure work for you when you find like hundreds of repos and hundreds of companies that are leaking these secrets?
If it's public,
yeah,
we email the committer.
Oh, okay.
And say, hey, do you know this is here? If whoever signed it. So if you're signing it with an email that doesn't work, know that we can't reach you and we can't tell you about it.
Makes sense.
So if some people really think that's a security thing. Like I don't want to use a real email, and Git has no way to check. But that's the disservice you're doing. Like, you as a committer can't be reached now. So who could tell you about any issues they find? So always sign. It doesn't have to be a good email. It could be like a Proton mail, but just make sure you're signing with something where we can actually reach you.
All right, thank you. Great talk.
Thank you. Any other questions other than that? Oh, one more, and then we'll call you the last question, and then we'll all go get some coffee.
I just wanted to point out with the SSH thing, like if you
Yeah.
use a Volt or any other SSH CA, like you don't really have to encrypt your SSH thing. Like you can use OIDC or whatever to grab yourself an SSH key, and then it rotates or whatever.
Unsigning an SSH key.
So if you use a SSH CA, like so Volt can act as an SSH CA.
Okay.
Or you can use SSH's own CA. But if you use Volt as the CA, then you can use like AD or any other authentication method to grab the key from Volt that it will then use to log you into the server. So then you don't really have to worry about password encrypting it.
I mean, at that point, you're signing it with the certificate authority, or that's taking care of this.
At that point, you're using some other mechanism to give yourself the key, and then it's signing it for you.
I think we're all on the same page. The more security you throw at it, the better. It's a matter of technical implementation at that point. No, you're right. If you're that advanced on it that you're using it to sign, then yeah.
Yeah, I was just saying
Yeah.
it's not going to be at all.
All right, cool. Hopefully that helps some people at home. All right, thanks very much, everybody.
Give it up for Dwayne McDaniel. Don't forget, there's a happy hour right now in the middle room. Tell everybody Dwayne sent you. I think you get a free drink.
Yeah.
I'm just playing. So no talks in here until 5 o'clock.
I forgot to tell everybody. I got stickers. You want stickers?
Dwayne has stickers.
Completely forgot to mention that. Even if you can get a prize. Thanks for the question, man. It's all right.
up my appetite. Don't leave me here high and dry. Oh, well, I don't wanna jinx it, baby, and twist myself at the spine. Don't wanna overthink it, baby. It's just twist your body and mine. Baby, you give me ice and fire. You're giving me wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, but I don't wanna jinx it, baby. Let's not get ahead of my time. Oh, but I don't wanna miss you, baby. So I stand up and speak just my mind. Oh. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, oh, some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, but I don't wanna jinx it, baby. Let's not get ahead of my time. Oh, but I don't wanna miss you, baby. So I stand up and speak just my mind. Oh. Baby, you give me ice and fire. You're chilling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, 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 kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, well, I don't wanna jinx it, baby, and twist myself at the spine. Don't wanna overthink it, baby. It's just twist your body and mine. Baby, you give me ice and fire. You're giving me wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, but I don't wanna jinx it, baby. Let's not get ahead of my time. Oh, but I don't wanna miss you, baby. So I stand up and speak my mind. Oh. Baby, you give me ice and fire. You're chilling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, oh,
All right, good afternoon, good afternoon. We've made it through almost the first day of BSides Las Vegas. How y'all feeling? Fantastic, fantastic. We have the amazing Dr. Matt Ware with us today, this afternoon. Password 911, authentication, adventures in healthcare. So somebody earlier said he saw him talk 16 years ago. So let's give it up for this man. He's been talking a long time, okay? All right, well, let me get some stuff out of the way real quick. First of all, your cell phones, turn them off. Again, unless it's God or somebody's dying, we don't want to hear it. Or at least turn the ringer off, okay? I want to take a shout out for our sponsors, the Diamond, Adobe, our Gold, Prism Cloud, Blue Cat, Plex Track, Toyota, all that good stuff. So without further ado, Dr. Ware, take it away.
Cool. Well, thank you very much. It's good to be back at PasswordsCon. The last time I spoke in person was in 2019 in PasswordsCon in Sweden, and a few things happened in the healthcare world since then there. So it's really good to be back here and talking about passwords and healthcare, which are two of my great big passions here. So in my day job, I'm a cybersecurity researcher focusing on trying to figure out the cyber resiliency for medical systems. So I both look at kind of the impact analysis side. So like a vulnerability comes out, you know, what is it going to be the clinical or the patient impact of this vulnerability? I also looked at this from the defensive side as well. It's like, how do we go ahead and design systems so when that next vulnerability comes out, they still are resilient. The patients can still have care, and we can still go ahead and do a good job. So as part of this too, I'm also a member of the Biohacking Village. So if any of you will show up at DEF CON over the next couple of days, we're going to have some medical devices for you to be able to hack and learn on, maybe apply some of these lessons that I talk about here too. As a side tangent, I was really pleasantly surprised by how easy it was to get medical equipment through TSA security. Like I was coming through here, and I was like, okay, this is gonna be the cover story. This looks dodgy as hell. You know, how are we gonna get this through here? And no problem. They were like, okay, it's not a bottle of water. We don't care. So just right on through. As it was mentioned a little bit earlier, I have been doing this a long time. I'm a long-time member of the John Ripper password cracking team because while I'm passionate about medical device security, I am absolutely obsessed about password cracking. So, whenever I get to, combine these two things together here, it's just a great day for me. So kind of talking about how long I've done this here, I was one of the first researchers to study the Rocky password list. So I was able to go ahead and grab it online. I published some analysis of this here. Other researchers were interested, so I shared the list with them. So if you're sick of the Rocky password list, I'm really sorry, okay? But if you want to ever have some good stories about that, talk to me afterwards about this. So one thing, though, I really got to have a disclaimer here is I am not a medical doctor. Don't let this lab coat here fool you. I got my doctorate in computer science and was really trying to model how people create and use passwords. And out of this came this PCFG password guess generator. And I've been talking about that for a long time, so this is a PasswordsCon, so if you'll just, give me a little bit of latitude, I want to talk about this a little bit more. Oh, and also before I can continue, if you were asking why I don't actually get any work done, it's just because of these, two little hellions here. So they're always walking across my keyboard and generating really good random passwords for me. So when I talk about the, PCFG password cracking, the kind of the base question is, what actually is that? And so the official term is it stands for probabilistic context-free grammar. And this probably doesn't mean anything to anybody here unless you're really into computer science or a grammar nerd or something else along those lines. And so I went ahead and I renamed it the Pretty Cool Fuzzy Guesser. And this kind of better describes what this actually does here. So basically, you train this on sets of disclosed passwords. It uses machine learning to go ahead and figure out probabilities associated with all the different types of mangling rules that people use. So sometimes you'll put capitalize the first letter, but they'll also capitalize the last letter at a certain probability. People usually add numbers to the end of their password, but sometimes they add numbers to the beginning, or they replace letters with numbers. And so what this Pretty Cool Fuzzy Guesser does here is it goes ahead and takes all the information and then generates passwords in probability order. So it'll generate the first most probable password guess, the second most probable password guess, and so on. And as you can imagine, this is really useful if you're trying to go ahead and crack passwords. So I'm not going to talk too much about this because I really want to focus on medical device cybersecurity. But there has been some work in this here that I just want to briefly mention. So the first thing that I've had really recently here is a default Russian rule set because I believe in kind of sharing this all around, not just focusing on all of us English speakers. So it's got a lot of new support now for cracking Cyrillic passwords. And you can find out more about that if you go ahead and read the developer's guide. I also added in honeyword and synthetic password generation. So what this does here is instead of generating the most probable password guess and then the second most probable one, it actually generates it according to the distribution that you would normally see in a normal population. So it generates essentially fake password dumps. So these are passwords dumps that look very realistic to what you find in the real world. And the question is why would you want to do that there? And really the kind of the main use case for this here is being able to help provision quickly large deception environments. Because no one wants to go ahead and generate 1,000 Active Directory user passwords by hand. And so this is a really good way to be able to make that, be able to fool an adversary. Based upon this, though, I also added in what's called a weighted random walk guess generation. So this generates password guesses the same way. So it will go ahead and just kind of randomly walk through the grammar and generate passwords. So by default, it'll generate the most probable password guesses first, but it kind of walks around and it causes a lot of duplicates as well. So the question is, why would I go ahead and do that? And the simple fact is that the PCFG password guess generator is slow. It's really, really slow. So it cracks passwords, but you generally want to go ahead and use other attack modes if you're not targeting something that's really computationally expensive. With this weighted random walk, though, it's fast. You don't have to keep track of states, so the memory requirements don't change over time. It's highly parallelizable because each guess is independent of each other. And what this really means is that it really kind of hopefully scales to a GPU password cracking type of a method here. So just to give you a preview of what I'll be talking about next year, hopefully, is I really want to go ahead and get this included into Hashcat there. So that's going to be kind of my goal there. But that's all really kind of to the side, because, what I really want to talk to you about, though, is passwords in hospitals. Because this is something that's really important there. With password cracking, we're getting better. I won't say it's a solved problem. The next talk we're going to hear is going to be really trying to get into that last hard part of it there. But there's a lot more problems here with trying to secure hospitals. How do we go ahead and be able to provide care in a kind of a hostile threat environment? And it definitely is a hostile threat environment too. Hospitals are absolutely under attack. So the primary people that are targeting them right now is your standard kind of ransomware type of criminal organization there, because they like the money and hospitals have money. I mean, that's really kind of what it comes down to there. So kind of if you look at what they're doing right now, it's kind of the standard that you see across any other industry there. They break in, they encrypt the files, they demand a ransom payment in order to decrypt them in order to do that. But hospitals have, luckily, and this is a really good development here, have gone better at being able to respond to this, because being able to provide uninterrupted clinical care is kind of core to their mission. So unfortunately, the attackers, they don't go, well, okay, no, this is getting harder, we're just going to walk away and target other industries. They've definitely been going ahead and changing their tactics as well. So recently, we've been seeing them go ahead and start trying to target like hospital support structures, like voice over IP systems. And it's really hard to run a hospital if you don't have a phone. Different departments need to call each other, patients need to be able to call it. So when a phone system goes down in a hospital, it's a really bad day. The other new tactic that's really been kind of popping up lately, and this is a really just horrible one, is extortion of patient medical data. So they'll go ahead and they'll break into the hospital, they'll steal very sensitive patient data, and then the hospital won't pay them because they're going ahead and they have recovery procedures in place to be able to respond to that there. So the hackers then reach out to the patients and say, hey, look, we're going to go ahead and publish this very, very sensitive data about you online, and then tell everyone you know about that sensitive data, unless this hospital over here that has all the millions of dollars goes ahead and pays the ransom. And so they're getting the patients now to try to pressure the hospitals in order to pay the ransom so that this data doesn't get leaked. And so you can see this is a really important problem for us to be able to solve, because we're all future medical patients, hopefully. If we live long enough, we are going to go ahead and end up in these types of systems here. And so same goes for everyone that we love and care about. So being able to provide safe and effective healthcare is a really important topic that I'm very passionate about. Now, one thing, and one of the reasons why I want to give this talk, though, is because our solutions have to fit into a clinical setting. There's no ifs, ands, or buts about that there. And so this really causes a lot of problems, because a clinical setting is very different from your typical enterprise system there. You don't want someone to go ahead and reboot the infusion pumps or something like that there when you're in the middle of receiving treatment there. You don't want your anesthesiologist to forget their password as they're trying to log into their computer or something like that. You don't want password change policies to suddenly break systems that are providing care. So trying to figure out how we can go ahead and secure the system and apply strong password policies and authentication mitigations into this here is really important. So I could keep on ranting about this, but I'd really rather talk about case studies here. So the first one I really want to talk about is controlled substance infusion pumps. So these are very common devices you'll find across hospitals, and they're used to dispense pain medication. So any of the really good drugs there that you can think of there, they generally fall into this here. And you don't want patients just to go ahead and open them up and start reaching in and start squeezing that bag of morphine really hard there. So pretty much the defining feature of a controlled substance infusion pump is a lock and key. So like here's one model here, there's where the key goes. Here's where, well, I guess that's a lock, but there they go for that. So if you go ahead and see a device with dispensing drugs that has a key, that's probably a controlled substance infusion pump. So this is probably the most common basic security password type of paradigm ever. You got something that's really valuable. You don't want people to go ahead and just grab it. So you put a door on there, you put a key on that door or lock on that door, and you call it a day. So this is pretty kind of a standard password type of a problem. So what if I told you, though, that this is also kind of a standard issue that comes up a lot, is about key reuse. And specifically, it's a common practice across all these different manufacturers here that they will use the exact same key on all of their devices. So for example, like if you go down to the hospital down here on the strip, you know what type of infusion pump they have, you can go ahead and get the key really easy and go ahead and log right in or and open it right on up. And as I said, this is very similar for all these pumps. So this is pretty much a universal thing. I'm not trying to give individual manufacturers a hard time. The only kind of disclaimer that I have is that you have a lot of these kind of third-party, plastic cases they put on there, and there's not really standardization of the keys for those simply because there's not standardization between the manufacturers. So this is the audience participation part here to talk. But is this a problem? Okay, we have some really important stuff. We don't want patients going ahead and squeezing it. We don't want people stealing it. We put a lock on there. We use the same key for every single lock all around the world. Is this okay? No? Well, I would actually argue it is, okay? Because you have to be physically close to this in order to be able to do this. This is not a remote attack. And if you start going ahead and opening up these infusion pumps and squeezing that bag really wicked hard, the nurses might want to stop you as well. And, so, this is not a huge problem. And on the other side there, physicians and nurses and everybody else need to be able to get in these pumps very quickly. And so these keys have to be very reliable because you don't want that to jam when you're going ahead and trying to go ahead and change a patient's medication. You also can't really change your treatment plans while that key is locked as well. So you have to be able to unlock it because you don't want patients pressing that button as well. So making sure that lock is really reliable, that can be opened in all types of situations, it has a strong failure mode and stuff like that there you don't have to worry about, is really important for providing patient care. So there's not really been any examples as far as I know either of patients actually compromising this. So the chances of someone having that key around their wrist when they get in a motorcycle accident is pretty low. So this is kind of an acceptable trade-off that most people take when it comes to password security or authentication issues when it comes to infusion pumps. So let's take this up a notch though. Should your pacemaker have a password? I know, yeah, everyone's kind of sucking in. It's like, yeah, that seems like something that would be really important there. We don't want people just going ahead and logging into pacemakers. And pacemakers are absolutely very connected. Like right here, you see like a cell phone. Okay, you don't want just everyone walking by, logging into your pacemaker there. And this is very important to enable. People always ask, like, why are we enabling this? Well, this is providing information to your doctor about how that pacemaker is functioning. Often pacemakers need to be tuned around and stuff like that there because it's it's a very delicate type of a thing. So being able to provide that level of reporting saves lives. So we can't go ahead and just say, we're going to go ahead and disconnect all these devices, make them dumb devices. We have to be able to enable this. But like even looking at this, like how does that pairing work? Like there's not a button on there I can push. Like, when I go to like pair my cell phone, what's that do? I do need to do like 15 minutes of cardio or something like that there in order to like get my heart rate up and accept that request. And I mean, the short answer, and there's a couple different ways to do this here, is that you'll have an app, you'll go ahead and you'll enter in your serial number into that app. It goes out to the manufacturer, and the manufacturer gives you kind of a rotating pin that you can then use in order to go ahead and pair your cell phone with your pacemaker. So I know we have a lot of security experts watching this right now, and you're like, okay, SMS, okay, that's a problem sometimes. There's challenges with this. How random is this serial number that there's actually being generated for someone to be able to guess? There's a lot of different rabbit holes that we can go down into the security of this here. But before we do, I just want to point out another different use case that will kind of negate a lot of that. And that is the pacemaker physician programmers. So the cell phones generally just report data about that operation there. But physicians need to be able to modify that treatment plan of those pacemakers as well. So these programmers, not only can they read data, but they can go ahead and set the settings of your pacemaker as well. And so that's really serious. And the other challenge is that often these devices need to operate in kind of an offline environment. You don't want to say, like, I'm sorry, we can't deliver life-giving care because our internet is off. So these physician programmers need to be able to access pretty much anybody's pacemaker. And this can happen whether you're here in Vegas, whether you're at home, whether you're in Australia, or anywhere else that you might need to be able to receive medical care. And so these programs are kind of interesting. Each manufacturer has a different one, so you'll often see them like just kind of stacked one upon each other in the hospital there. Each of these will also be running a bunch of different apps on there for each different model that they want to be able to support. If you look at that GUI and you're like, wow, that's really old. Yeah, you're right. It's about 3 years old there. But you have a GUI that works in a hospital, healthcare system. Why bother to update that there? So how do you secure this? Okay, this is something that has to be able to access pretty much anybody's pacemaker. You have to be able to go ahead and distribute this, all over the world, basically. You can't really have that functionality to phone home to a centralized database to be able to receive these, whatever security code that you have. Like, how does this work with passwords? So like, one thing they might start to think though is like maybe the manufacturer really has some proprietary algorithm that no one can reverse engineer, or maybe we like hard code the password onto here and really try to keep these programmers safe. We really try to lock them down and ensure that they don't get out into the wrong hands. And oh well, that's not going to work. So these things show up on eBay as well. Being able to maintain physical security of these devices is very hard. So one thing I just want to highlight is, I've looked at this here. I actually haven't bought one of these. Doing pacemaker research is actually really hard because you don't want to be like, oh, I wonder what this does, and then someone just drops dead outside your hallway. This is definitely something that you need to worry about. When we talk about, the threat level to be able to do this here, adversaries, if they really want to be able to get into this here, there are definitely ways that they can be able to obtain these types of devices. Now, I want to take a kind of a step back, though, okay? And it really just kind of ground this, because I don't want anyone to leave this scared, okay? These devices, they save lives, full stop. I have people that I know and care about that have connected pacemakers, and I am okay with that, because the value of the care that they're receiving from that there is way outside the risk that they could potentially be having. There's also no evidence of any implantable devices being exploited in the wild. So while we're basically talking about theoretical attacks that could potentially happen, they're not saying that's currently being exploited. And then the level of expertise and resources to develop these work and exploit is non-trivial. Okay, it does take work. And luckily, the Venn diagram of people that have the technical skill to be able to do this and people who want to kill people is pretty low, as far as overlap goes. But I want to have a better story than this, and this is why I'm giving this talk here. It's because I really want to inspire everybody here to really start trying to figure out better solutions. Because we have to enable this connected functionality. We have to even add to this connected functionality, make it even better, make it more connected so that we can start getting data in order to save people's lives. But we also want this to be safe, and we don't want to have any caveats. We don't want to have anybody worried about whether they're going to be hacked by their pacemaker or not. So we really need to get together as a community and figure out secure solutions in order to be able to address problems like this. So some of the key topics I'm going to be really talking about here and kind of harping on is, first of all, when we talk about medical devices and stuff like that, what we're really talking about is medical systems. Like, everyone focuses on the end device that you can buy on eBay, but it's connected to all these other different types of systems, and that's the whole reason why we're making that connected in the first place. So trying to understand the whole security of the system of systems is extremely important. The other thing I really want to highlight is the idea of resiliency. So, devices are going to get hacked, keys are going to get leaked. The real important question is, how do we still, maintain and deliver safe care to people when these problems happen? So, for example, like with the pacemaker option, we might not be able to have a password with that. So what else can we do? Maybe and I know this is a hard problem to ask for, at a PasswordsCon conference, but like, are there non-password solutions that we can have? For example, like, can we have better reporting? So that way we can say, if something does happen, we're able to detect it very early and we're able to respond to it. One thing that manufacturers do is they have safeguards in these pacemakers. Mostly they're from a safety standpoint. You don't want the physician to hit the wrong key or have to walk over their keyboard or something like that, and all of a sudden, for it to cause harm to a patient. So a lot of times these devices, you can give them, bad data, but they'll fail into a safe mode that will still provide, not great care, but at least some level of care for them. So maybe you go ahead and start doing that in order to be able to better secure it. So even though anybody can log into this pacemaker, they have a harder time actually causing actual physical harm. But what I really want to inspire people to do is start thinking like as a system of systems and outside the box of how do we go ahead and secure and enable these really hard clinical use cases. So let's have another case study here. Stored credentials. We've heard about this quite a bit, actually, from all the previous talks that we've had throughout the day here, and I'm sure we'll be hearing more about this later, too. So medical devices store credentials just like everything else. So here's a CVE, and it's basically for an infusion pump, and I'm sorry about all the words, but really what it boils down to is that the CVE came out and said that an attacker may be able to obtain unencrypted wireless network authentication credentials to the hospital by disassembling one of these infusion pump units and just reading the flash drive. So the caveat there was, accessing the internal flash memory would require specialized tools, and then like nurses might get a little bit annoyed at you too if you're going ahead and just unscrewing these on the ward there. So that was really kind of what it was saying there, and the kind of mitigation saying that this wasn't a really big problem. So my question to the group, I want this to be a little bit more interactive. Is this a problem? Wi-Fi credentials to the hospital stored on a medical device that you have to physically open up in order to extract a flash drive in order to read. Who thinks that's a problem? Oh, we got a few hands here. Okay, guess what? I'm with you there, okay? Because that doesn't have to be in a hospital when you go ahead and extract that data. So here's a bunch of the infusion pumps in that CVE listing there. They're a lot cheaper, so we went ahead and bought one. And so here is that infusion pump in our lab. We name everything after Simpsons characters in our lab because that brings me a lot of joy. And so, there's me opening up. There's a tamper-evident seal that was just a sticker. And I'm actually kind of cool with that security feature because, it doesn't. I'm not going to report it myself, so having a really good tamper-evident seal isn't that important. And it's probably worth that 1 penny so the board biomed just doesn't start unscrewing it and and when they're messing around with it and stuff like that. There's the flash card in it. And so there's me with the proof of life of that flash card there. So, being able to, pull that out is a very realistic, type of a threat there. Now, one thing I want to say, though, is, after all that work there, I actually didn't find any credentials on that particular model there. But what I will say is I have found lots of Wi-Fi credentials on other eBay purchase equipment that we've bought as well there. So this is absolutely a very real thing. The disclosure is always a pain as well because she's like, it's like, oh my God, I hope there's not patient data on here as well. So you have a lot of fun talks with lawyers when this happens here. So this is an example, though, of device retirement. So this is something that all devices go through. The device, gets used, and someday it doesn't get used. It gets, replaced. It's either thrown out or sold on the secondary market. And then you need to make sure that that's done securely there, because people don't change their Wi-Fi passwords very much, especially in high-value environments there. So one thing that I really kind of believe in is the idea of threat modeling, and so this is something that our team's really been involved in quite a bit. A couple of years ago, we published a playbook for threat modeling medical devices. This was sponsored by the FDA to really try to get threat modeling involved early on in the development of medical devices there. And throughout this, we have the idea of kind of example of high-value data flows. And these are common things that a lot of medical devices do that have a lot of security problems. So device retirement, that has a lot of security challenges that can occur there. It'd really be nice if we started seeing more advanced techniques like TPMs or other types of things. Like your cell phone is pretty good at being able to secure all these different things even if you lose it somewhere. So there's a lot of different other kind of high value data flows that tend to trip people up as well. So in this playbook, what we did was we have a bunch of example fake but realistic kind of looking medical devices. And we start walking through kind of how you go ahead and do threat modeling of these devices as well as common problems that occur. So a big one that we have is software update. Software update is a really important thing. We want to be able to make these medical devices be responsive to attacks when they come out. So being able to update the software provides a really good mechanism for that there. But it's really hard to do secure software update. There's a lot of things that can go wrong. And so one other research question I kind of like to put out to the whole audience here is, how do you do this? And how do we make this easier for medical device manufacturers to actually implement? Because trying to implement secure software update, especially for some of these, not real-time operating systems and stuff like that there, is actually non-trivial. And if you're wondering, do people get them wrong? Absolutely. Okay, so here's another CVE. This was also for another infusion pump. And basically it says application does not restrict the upload of malicious files during firmware update. So there was no device signing, there's no authentication. You just plop an executable in there, it's like, sure, sounds good, and it goes ahead and installs it. So I'm not the greatest hacker in the world, but even that level there, I can go ahead and be able to deal with. So this is another example, though, from credential management and stuff like that there, of being able to properly sign software updates, be able to distribute them out there correctly and stuff like that is a really hard problem to be able to solve that pops up in pretty much all these different types of medical devices out there. Now, I've been giving a lot of different infusion pump examples here. And, the initial thing might be like, oh, my God, infusion pumps are really insecure. And not completely wrong. You know, the reason why we see all these different vulnerabilities pop up about them there is really it comes down to they're cheaper than MRI machines. When you start looking at other medical devices, you see a lot of the same problems. That's actually one of the things where I love being in cybersecurity for medical devices is because it feels like I went into like a time machine. And I'm suddenly back in the 1990s, like, oh, look, Telnet, hey, cool. You know, there's a lot of different, you know, there's a lot of room for improvement in medical device security in order to be able to get them to start using more modern protocols and be more resilient here. But I have to say, I'm cautiously optimistic because, you know, the security research that we're doing right now is having a huge impact. And I really do believe that security research acts a lot like a vaccine there. You know, you're basically stressing the organism in a way that's, you know, safe. And it develops defenses against, you know, what those stressors are. And so in this case, it's cybersecurity. We're stressing these infusion pumps here. And across the industry, we're really seeing that infusion pumps and infusion pump manufacturers are really kind of taking notice. So there's a lot more guides of how they go ahead and secure devices securely. And they're starting to implement much better security there. The really big problem, though, is legacy systems. You know, hospitals just don't go ahead and update their systems all the time there. So these systems that you hang around for a long, long period of time. And then the other thing that I really think is kind of important is how do we, you know, translate the lessons learned from these types of devices and this type of research there to all the other types of devices in a hospital? Because we don't want to go through this long, painful process with every single device in that hospital. It'd be really nice if we could kind of learn from everything and go ahead and develop more secure solutions and really apply that to other people as well there. So I've been on my high horse a little bit too long here. So let's talk more about, you know, other types of examples that, you know, kind of pop up here in healthcare. So electronic health record systems are really kind of the core of any sort of hospital. If you follow any sort of cable from any medical device in a hospital, and you follow it long enough through all the different wiring closets and stuff like that there, eventually you're going to end up at an EHR system, okay? Because this has all the data about all the patients that you care about. So this is you know, what we use in the lab. We have OpenEMR because it's free, and once again, that's kind of nice. But this is actually an EHR that's actually used in a lot of smaller organizations as well because it's free, and you don't want to have the $1 billion to spend on Epic or Cerner. We also just, and kind of a quick shout out, we use synthetic patient records for this. So there's a project called Synthia that allows you to generate very realistic synthetic patients. So this will have, you know, they'll have the proper comorbidities, so you're not having like a baby with dementia. If you squint at it, it looks like, you know, a realistic patient, and that way you don't have to worry about dealing with NAPII when you're doing any of your research there. So these electronic health record systems, though, they need to be connected to a lot of different other types of systems. And so you start thinking about this, and you look back at the couple of, you know, previous talks that we had in this track here, and that means APIs. You know, everyone's, you know, favorite, you know, thing that we're talking about when it comes to computer security. So there's a lot of different ways to be able to connect to these types of systems. Basically, one of the newer ones that's really kind of interesting is called the Fast Healthcare Interoperability Resource Number 1. And it's a fairly new standard. It's only about 10 years old. And number 1, as you can see, it's, you know, they're still trying to build it out. But it's a lot better than the previous standard called HL7, which it's like vibes of a standard, kind of. It's not really a so, you know, with FHIR, it's a pretty good way to be able to transfer medical records between different devices. And because it is a newer protocol, it does support other types of, you know, newer authentication mechanisms as well, like OAuth 2. And so OAuth is pretty good, actually. Okay, I mean, I see a couple people nodding, like, okay, you know, that's not horrifying. So that's pretty good there. So that's really good, and that's really optimistic there. But the problem is, what happens when we take, you know, these protocols that we're using in a hospital, and we start trying to go ahead and use them to enable other types of healthcare delivery options there. So a good one is kind of aging at home. You know, we want to go ahead and move more, you know, medical devices and, you know, healthcare, you know, systems into the house. So that way you don't actually have to go to the hospital. You can get better care at home. You want to be able to see your patient records, which is really important for everybody as well. And then we also have a lot of different other areas too, where we want to be able to, you know, interconnect different companies together. We want to be able to interconnect different services together. We want to connect this to the cloud. So, you know, how does this go ahead and work? And the short answer is there's some growing pains. Recently, or a couple years ago actually, but it was a number of really kind of interesting vulnerabilities came out called Playing with Fire. And the work that Alyssa Knight and her team did was really kind of cool. They found a lot of different challenges with basically trying to analyze web apps, on your phone that connected back up to EHR type systems there. And while they found a ton of different problems, really the core one that I kind of narrowed in on there was that a lot of these patient apps here focused on authentication but not authorization. So they would make sure that they authenticated you really well. They would make sure that you had an account on the system, that you were actually who you were talking about. And you'd say, I want everybody's record. And it goes, sure. There you go. You can have whoever's record that you want there. So what it really boiled down to is they didn't implement a whole lot of server-side controls. So they make sure that you actually had an account to get in the door, but once you're in the door, you could go ahead and take out everything that you wanted with that. And kind of the question is, why didn't they think of that there? That seems like a pretty, really, basic or important type of a thing. And my hypothesis, kind of looking at some of our EHR systems here, is hospitals really don't work that way. A hospital, you're not trying to say, okay, this patient only has access to this one piece of data. What you're trying to say is this medical device has access to all this type of data here. So, okay, this one can have access to your dental records. Okay, this one can have access to your x-rays here. Or this one here can have access to, your billing information for some reason. So when you look at, how you go ahead and specify authentication and authorization with these devices here, it's really these broad categories that these really focus on. So this works good in a hospital. It causes a lot of problems when you start just taking these protocols like, willy-nilly and trying to move them to kind of a patient-facing app where you say, you really only need to have access to only your data. And so I suspect that this is going to be an area where we're going to continue to see a lot of challenges with, over the coming years. And so from a security researcher standpoint, I would say this is something that you should probably almost immediately look at when you're trying to analyze these health apps. Are they actually having any sort of authorization as well as the authentication that they're doing there? So getting back to the patient bedside though, let's talk about service PIN codes. So if you find something in a hospital and it has buttons on it, it probably has a hard-coded, unchangeable service PIN code that you can use in order to enter into kind of some restricted mode in that. And once again, this is a universal issue. It doesn't matter, as I said, if it has buttons, it has a back-end, hard-coded password on this. So this is kind of, once again, here's our lab. Of course, because I can't remember these, we wrote them down on a piece of paper and just taped them onto the device here. So now I have to say, I've been doing password cracking for a long time. I know a lot of good reverse engineers too where I work. So the question kind of comes down to how do we find out this data here? Do we have to go ahead and crack this open, pull out that flash card again, start reversing this, extracting these passwords? There was a previous talk about reversing mobile applications. Do we need to go ahead and do this in order to get the those service pins? And the short answer is I'm lazy, so no. I just go ahead and I download the manuals. And then, somewhere in there, this was in chapter 1, here's all those PIN codes for that right there. So I heard some people saying, oh, no, here. I guess my question to you is this a problem? Who here thinks this is a problem right now? Okay, let's get some hands up here. Oh, we got a couple of them. Yeah, we got some wavies as well. I actually will say I don't lose any sleep about this here. Okay, I don't think this is a problem because I kind of factors around to having that physical key. If you're physically there and are able to start pushing things into the button and it's that there, if I'm connected to that device, I'm not gonna be doing that because I don't want to be like, haha, I pwned the device and you're dead. Yeah, so I really don't have too much of a problem with these physically, you have to be physically there in order to be able to access these modes, because it's really the main goal for this here is just to make sure that a nurse doesn't accidentally change the IP address of a device here, or a patient just doesn't start messing around with it and get into an unsafe mode here. But it's not really a real secure access control that needs to be kept secret from everybody. So what about hard-coded remote passwords? So this is a problem here. So I was kind of curious about trying to figure out how big of a problem this is. So I work at MITRE, and so we're all about our different enumerations. We have, a million different ones there. You hear about attack, CVE, CWE, and stuff like that there. So CVE, Common Vulnerability Enumeration, is a really good way to be able to kind of see what vulnerabilities have come out in devices before. But there's a lot of vulnerabilities that come out. So being able to narrow your search for them is a little bit hard sometimes. So one thing I want to kind of highlight is CWE, Common Weakness Enumeration. So you can say, I want to find out this particular type of vulnerability, like use of hard-coded credentials. So why don't I go ahead and search all the CVEs for this particular CWE and see which ones pop up here. And the short answer is a lot, okay? And actually, I was surprised by how few I found, because I've done a lot of work with medical devices, and I've definitely seen a lot more medical devices that had hard-coded, unchangeable, remotely accessible passwords than what pop up here. So this is a real problem, okay? And this is definitely something that we do need to be able to address, and this is something I'm a lot less forgiving from when it comes to trying to assess the impact of these security vulnerabilities here. Now, there's definitely other mitigations that can be put in place in order to try to limit the damage that's done by these here. But this is something that going forward, I would really like to see less of here. So, we talked about a bunch of different types of password vulnerabilities with different medical devices here, and I didn't offer a whole lot of solutions as well, I have to admit. And I'm very aware of that, and that's actually one of the big things that really spurred me to have this talk here. Is we need more cybersecurity researchers in the medical field. There's a lot of different work that needs to be done, and I don't want anyone to leave here afraid. I don't want you to be afraid of receiving medical care. I don't want you to be afraid for your loved ones here when they're receiving medical care. But I want you to leave here inspired. I want you to leave here really determined to kind of look into different types of medical devices and really try to start doing some of this research. And it's fun work, it's impactful work, and there's a lot of low-hanging vulnerabilities for you to be able to deal with as well there. So one other thing I really want to be able to highlight, though, is that the solutions that you come up with have to fit into a clinical setting. Okay, you have to really always keep that patient's care at the forefront of your mind. So making sure that's available, making sure that these workflows are able to work is probably the #1 priority there. And so we have to make sure that we have to change our security practices around that versus trying to change these clinical care workflows in order to fit into our security methods here. I also really am a big fan of threat modeling. I really think that if people just start doing threat modeling, that really can be help win the war a little bit here. Being able to at least try to identify what are the threats, what are the trade-offs that we're making, and how are you going to go ahead and address those threats there as well. The other thing I really do strongly believe is that cybersecurity is too hard right now. Okay. Medical device manufacturers are not going to go ahead and focus on cybersecurity. That doesn't make money for them there. So what we need to do as a community, though, is make cybersecurity easier. So that the way it's easier for them to actually implement devices in the right way than just trying to roll their own solution there. So come up with common practices and common libraries. Like how do we go ahead and do authenticate for pacemakers and stuff like that there, and come up with standards for that there. I think is a really important area of research for us to go forward with here as well. But really, at the end of the day, it's really important that we can't say no to all these different options. Like someone's going to say, I want to connect, this medical device to the cloud. And I mean, our gut feeling is like, no, don't do that. Don't connect that to the cloud. I don't even like connecting my home, smoke alarm to the cloud or anything else along those lines. But we really need to be able to enable this. We need to say yes. We need to be able to do this so that people are able to receive effective care going forward. So that's really kind of my stump speech here for the importance of this work. I hope that you're inspired by this here. I love talking about this, so feel free to hit me up really whenever, and I will rant your ear off about this. And I really want to learn from you as well here. And also come visit the Biohacking Village later on if you actually want to hack some of these devices for real as well. So with that, does anyone have any questions? Right in the back there.
I've got a question, Matt. So I used to be thank you. Matt, I used to be a paramedic, and now I'm in the cybersecurity field. And I'm curious, I got 2 questions. One's long, one's short. First one is, how do you deal with what's your personal philosophy on dealing with cybersecurity in medicine of that, like, emergency situations need to have, break glass in case of emergency, those keys, versus keeping things secure? So that's the first question. The second was, are you guys hiring?
So I'll answer the second question first, yes. Talk to me afterwards. For the first one, I will say I am all for break glass at the end of the day. Once again, kind of going back to that bullet point earlier there, I think we have to be able to enable those clinical workflows. Like, I forget my password all the time. I mean, that's just the case there. I don't want to be like in the doctor's office, like I forgot my password, and they're like, well, guess we got to operate you on you to take out that medical device there. That's just not an acceptable answer that I'm willing to take. So we really have to be able to enable all those break glass options there. And that causes a lot of problems because that means that passwords are a lot harder. We have to be able to allow people that may not be good actors in order to be able to break that glass as well. So coming up with other resilient options. So when that glass is broken, your house still doesn't get completely ransacked. Maybe safes for your important data or something like that there. So long story short, I'm absolutely on the break glass functionality there. I'm availability and being able to provide care over following just kind of a standard security thing. We need to update security in order to enable those that functionality. Yep, you have a question right there. Yep.
Thank you, Matt. Great talk, obviously. So kind of to pivot with that same break glass emergency sort of thing, I work for the Defense Health Agency. And so one of the things the first thing we always say is patient care is first, right?
Mm-hmm.
What happens when our medical professionals start to weaponize that against us? So when we start to make what I consider the very basic cyber hygienic policies in place, they fight saying like, oh, this might kill someone. I was like, sir, your ability to watch YouTube videos is not going to kill a patient. But I can't. But like all the veterans in the room, I'm really sorry. That's an actual real case study. So like how do we basically, in your opinion, like what's the right balance of like, no, we really want you to save people, but also don't be a dick about security?
Mm-hmm. That's a real hard question, and certainly one that I'm certainly struggling with myself here quite a bit because I like watching YouTube videos too. But I think it's really a conversation, and that's where I'm actually kind of a fan of threat modeling. If we tell people like you got to implement a security process, and they're like, no. You need to come back and say, okay, here's why. And you kind of walk them through it. Because if you tell people like, okay, the hospital over there got hacked because, they enabled, internet access to this, clinician-facing, computer here, and malware got into that, and then it ransomware the hospital there. People can sort of start to understand it. And you still have to have a conversation because they're like, well, I'm not going to click on that link. But being able to really kind of walk through these types of threats, really try to walk through the procedures, and then maybe come with an alternative option, like, okay, you need to be able to show YouTube videos to your patients because there's a lot of useful healthcare information. Why don't we go ahead and make another laptop available for you to be able to, have this really important interaction that you're having with your patients as well. So I certainly haven't found a good answer to that question. It's one that's going to continue to pop up all the time. I mean, I know, like, I'm a bad user too. Like, when my corporation says, like, okay, you need to change your password, I'm like, I've done a lot of studies that say you don't, and it's not helpful. So having those interactions and stuff like that there, it's really tricky. But we need to kind of come to the table with them as well to try to figure out alternate workflows for them.
Botnets have been a very, very critical, attack vector for all these medical devices. So the problem lies with the device manufacturers not abiding by a process, supply chain, validation and stuff like that. So how does Mitre take this to a next level to better educate the actual vendors of these devices and supply chain?
So that's a really good question there. Everyone has a role when it comes to the medical device security. Patients have a role, doctors have a role, hospitals have a role, medical device manufacturers have a role. The thing is, when you go further upstream there, the more resilient the system becomes because, like, trying to expect users to be secure is just, not going to work. Trying to expect doctors to be secure, you're going to have exceptions there. Trying to expect hospitals to be secure, you're going to have exceptions there. So trying to move that up and really focus on the medical device manufacturers can have a huge impact throughout the entire industry there. Now, I mean, the challenge there is, how do you actually inspire this? And so one way is, with legislation. So, there's a whole I am the cavalry track here that really focuses on policy. But that's a dirty R word there. You have to be really careful about that as well. So the other thing I think is really kind of important is just making it easier for medical device manufacturers there. So, expecting them to have a cybersecurity and password and authentication expert on our team is just not realistic. I mean, there's just not a lot of those people out there, and let alone, for these smaller device shops here. So, having practice guides so that when they go ahead and say, I need to make this device, I need to get it through, FDA certification, I need to go ahead and do all this stuff here. Hey, I can go ahead and use these libraries. I can go ahead and use this, follow the standard practice guide that's been put out there. That's just easier, than trying to roll your own solution and do it. So if we can go ahead and make security easy, that's really the way to be able to inspire them. And so there's different resources available for medical device manufacturers. So the NIST, National Cyber Center of Excellence, publishes some implementation guides that are really useful for different areas there. So they have one for like telehealth, one for infusion pumps, and so on. As I mentioned, like we've authored a playbook for threat modeling medical devices. Now we're starting to need to be able to do threat modeling if you want to get your device through certification. So being able to kind of use some of the lessons learned in that playbook there can be very useful for you as well. And then just being able to use kind of standardized libraries, and there's a lot of overlap now with like IoT. So you see standards like Matter that are coming out for the IoT setting, and medical devices look a lot like your smart door lock, or something like that sometimes too. So especially when you're starting to move them into the house. So as we start to see, security features being used across other industries, trying to figure out how medical device manufacturers can implement them is nice, because then they don't have to roll that themselves. So that, once again, it's just easy for them to be able to do. So long story short, the easier that we can make it for them, the better off we are. And I think that's really how we implement change in the industry. Any other questions? Oh, one way in back again there.
Matt, going on the same track, because I've seen the same thing, like these companies don't have a whole lot of budget for doing cybersecurity. Has anyone proposed a distributed model, kind of like an MSSP, but for healthcare, where you have like a whole bunch of small shops pitch in a little bit to sort of pay for a cybersecurity professional that can evaluate their software to make it affordable?
There definitely are industries that are popping up there, because the second you say, this is hard, we want to pay somebody, people are like, I can do that. So I really don't want to kind of start listing them off, because I don't want this to be, the highlight one or the other. But there definitely are, especially if you go to, like, let's say a conference over there, down the way there, there'll be a lot of vendors that will be telling you how to be able to do that. And I think that's actually it's a very important niche to be able to do, because having that cybersecurity professional and then being able to pay for them, on your staff is very hard to be able to do as well. So we're seeing that a lot for hospitals, because they just don't have that cybersecurity professional on staff. They have someone to patch systems, but they don't have someone that's really aware of all these different types of systems that come into their hospital there. So there is a lot of outsourcing that's going on currently in the industry for that there. I don't know if that got anywhere near your question or not, but and there's definitely areas there. So if you're thinking of a startup, that would probably not be a bad one. So. Cool.
Matt, I just want to say thank you. This is a very important topic for me as well. I've been in the healthcare industry my entire career, most of it in audit compliance. And these doctors will straight up tell you, I'm not doing multi-factor because somebody's going to die, right? Or, it's really real, especially in the public safety period. These firefighters, EMS, you guys are doing your job. So I appreciate your comment about making it easy, bringing it to them. So I guess you pretty much answered my questions when it comes to supply chain, vendors having that responsibility. But do you have any other specific suggestions about how to make it easy? Do you think it would be more like just security awareness training, like having that hand holding? How can we really drive it home to make these healthcare providers understand the significance of security?
I'm still trying to figure that one out myself, just to be full disclaimer here. That's a really hard problem to be able to solve. I think it is kind of like a whole of industry there. So you're trying to get security decisions built into the decision-making process for hospitals and purchasing process for hospitals is actually really hard to do. And there's not an easy way for hospitals to be able to evaluate the security of their systems as well. Like, you'll get a fact sheet from the medical device manufacturer saying, yeah, we're totally secure. And it's like, okay. So we're starting to see things like, SBOM coming out, software bill of materials for medical devices. But even that, you get a list of all the different software in a device, and it's like, okay, I mean, what am I going to do to make use of this, especially in a hospital setting there for being able to incorporate this? So trying to figure out how we start making use of this type of information in order to help influence purchasing decisions, I think is a really important area of research to be able to do to help kind of spur that there. I think hospitals themselves, though, are actually kind of really coming on board. I mean, they're being hacked at the end of the day. I mean, and that's a tremendous motivator to be secure. So I think the big challenge right now is that they're responding to, they're doing triage, just like any other type of medical care there. So they're responding to, the hacks that they're dealing with right now there. So your standard, as I said, your ransomware, they're really focusing on that. If you talk to any CIO or president of a hospital there, they're going to, mention their, backup procedures, their ability to be able to detect the adversary. But when it comes to these medical devices, a lot of times right now, they're like, no one's targeting them yet, so we don't really, that's not where we're going to focus on. And I think that's an area that really requires a lot of work as an industry to really try to get these devices secured before the hackers start focusing on them. Because, once they start focusing on them, that's really going to be a bad day. So I really want us to get ahead of that curve there. So once again, not really answering your question, so I apologize, but it's a hard question to answer there. We're getting yeah, so a gentleman in the audience here just said that, it was a further confirmation that working in healthcare, doctors and patients will just kind of do what they want. So that's a challenge. So thank you very much. I really enjoyed talking here again. I hope to see you again next year. You have a good BSides.
up my appetite. Don't leave me here high and dry. Oh, well, I don't wanna jinx it, baby, and twist myself at the spine. Don't wanna overthink it, baby. It's just twist your body and mine. Baby, you give me ice and fire. You're giving me wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, but I don't wanna jinx it, baby. Let's not get ahead of my time. Oh, but I don't wanna miss you, baby. So I stand up and speak just my mind. Oh. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Baby, you give me ice and fire. You're channeling wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite. Don't leave me here high and dry. Oh, oh, Baby, you give me ice and fire. You're giving me wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my